काय झालं ते?
जरा चालू झाला. बोल सर.
National Seminar on
और अगर दूसरे बच्चे भी आ जाते थे तो अपन खड़े अब
फालतू पण दोन्ही वेळ पण मग कुठे जम्बो जम्बो फिरायला आहे वाटतं.
नाही
A very good morning to everyone present over here. I take this privilege to warmly welcome all our delegates on this national seminar on recent advances in chemical science and technology organized by Department of Chemistry, Vasantrao Naik Mahavidyalaya Aurangabad. A very warm welcome to all for gracing this seminar with your presence. My name is Talat Muniza and I am delighted to be your anchor. It gives me immense pleasure to extend a very warm welcome on behalf of Chemistry Department who has clubbed all of us for the virtual national seminar. I welcome our Honorable Chief Guest, Dr. Mazhar Ahmed Faruqi Sir, Principal Maulana Azad College, Aurangabad. I also welcome Chairperson, Secretary Nitin Rathore Sir, and our Principal, Dr. Anand Chaudhary Sir, Vasantrao Naik Mahavidyalaya Aurangabad. Before we start, ladies and gentlemen, I would like to take a few moments in introducing our renowned college. Vasantrao Naik Mahavidyalaya was started by Vasantrao Naik Shikshan Prasarak Mandal in 1972. It was the product of vision of Samaj Bhushan Principal Rajaram Rathore Sir to start an institution for the advancement of socially and economically underprivileged. Principal Rathore Sir was influenced by great visionaries such as Jyotiba Phule and Dr. Babasaheb Ambedkar. As this 2022 and 2023 is our golden jubilee year, our college have completed 50 years. We are all so proud celebrating this golden jubilee year. The college is permanently affiliated to Dr. Babasaheb Ambedkar Marathwada University, Aurangabad, accredited by National Assessment and Accreditation Council, NAC, at B++ level. National Seminar on Recent Advances in Chemical Science would serve as a common platform for scholars to share their findings and ideas in various areas of chemistry. This seminar aims to promote the interaction of researchers and the sharing of ideas, experiences, and expertise in chemistry-related fields by providing opportunities to discuss recent and new findings. Nanotechnology is a relative new science that has generated tremendous excitement worldwide. With the latest advances in this field, scientists are developing state-of-the-tool art and product to address pressing needs in various fields of research, including health, environment, and sustainability. Now, I call upon our convener, Dr. Jagdish Bharar Sir, head of Chemistry Department, to express his views about the seminar. So,
good morning to everyone. Welcome to National Seminar on Recent Advances in Chemical Science and Technology. Respected Chairperson of this session, Shri Nitin Rathore Sir, Secretary, Vasantrao Naik Shikshan Prasarak Mandal, Aurangabad, Chief Guest and Inaugurator of this seminar, Professor Dr. Mazhar Faruqi Sir, Honorable Resource Persons, Rajesh Bhosle Sir, Dr. Kaide Sir, Dr. Shingte Sir, and all dear participants. On the occasion of this golden jubilee of Vasantrao Naik Mahavidyalaya Aurangabad, Department of Chemistry has planned to organize online national seminar on Zoom and YouTube platform. Since COVID pandemic, we are all familiar with online platform to use it in educational process. Online seminars provide an effective way for pupils to connect and exchange the ideas. It is cost effective and accessible to all. Such online seminars can provide a platform for networking and collaboration between individuals and the organization from different locations. In future, we know online mode or blended mode of teaching learning methods may included in educational system. The aim of the seminar is to sensitize and stimulate the young minds to bring out the best among the various frontiers of chemical sciences. So this seminar would generate awareness amongst the budding researchers. The objectives of the seminar are to discuss and promote the recent findings and recent trends in chemical sciences, to promote premier scientific forums for students, researchers, scientists, and academicians to navigate the future research for the betterment of the society. The national seminar has been an inspiring opportunity to discuss and exchange ideas on some of the most pressing challenges in this field. We hope that the discussion and insights shared during this seminar will help to stimulate progress and advancement in chemical sciences and technology. We feel glad to inform you that more than 250 participants, including academicians, research students, PG students of different institutions from all over India, have registered for this seminar. It is due to the network of researchers under ACTRA, Analytical Chemistry Teachers Association, through which more than 500 researchers bonded together for sharing their research ideas and work. And the mentor of this ACTRA, respected Professor Mazhar Farooqi sir, who have united this team of researchers. Let me share the brief information about our department. Department of Chemistry is having recognized research center in chemistry for PhD degree by Dr. Baba Ambedkar, Vasantrao University, Aurangabad. There are 25 students now working under the guidance of 4 research guides. Since last 17 years, postgraduate department of postgraduate chemistry program is run successfully by the college. Faculty members of department is actively involved in the research through paper publication and research projects. They have completed major and minor research projects of DST, UGC, and university. Around 500 research papers published by the faculty members in national and international reputed journals. I would like to place on record our immense appreciation for the presence of our resource persons, whose valuable insights and opinion will be extremely helpful in exploring the present seminar. Their words inspire us to create a better future for all. So on behalf of organizing committee, I am very much thankful to all you participants, our resource persons, and chief guests. Thank you one and all. Thank you.
Thank you, sir. Now I request our principal, Dr. Anand Chaudhary, sir, to say a few words about the seminar.
Namaskar. Fresh morning to one and all. Vasantrao Naik Shikshan Prasarak Mandal, Vasantrao Naik Mahavidyalaya Aurangabad, Arts, Commerce, Science, and Management Science faculties, our institution celebrating Golden Jubilee year 2022-23. On this auspicious occasion, we are organizing this online national seminar on recent advances in chemical science and technology. For this auspicious occasion, all the dignitaries participating here, it's my prime responsibility to welcome all of them. Vasantrao Naik Shikshan Prasarak Mandal, President Samaj Bhushan Pracharya Rajaram Rathod sir, Honorable Secretary of Vasantrao Naik Shikshan Prasarak Mandal, Shri Naik Mahavidyalaya Aurangabad. For this inaugural ceremony, the keynote speaker, Dr. Mazhar Faruqi, Principal, Maulana Azad College, Aurangabad, the convener as well as the head of the Department of Chemistry, Dr. Jagdish Bharatji, our IQAC coordinator, Manisha Rugre Madam, the entire team of this Department of Chemistry, my senior and junior all colleagues already participating and registered with this Zoom platform, and all the near and dear participants registered here throughout India. It's my immense pleasure to welcome all of them. Friends, our institution is in the state Maharashtra in India, already completed 50 years and NAC re-accredited institute. Our country has a rich history of educational as well as social services. And all these are blended with the human touch for economically and socially poor and weaker sections, especially from the rural youth, in order to pursue their higher education. To cater the need of socially and economically weaker students, our Honorable President, Vasantrao Naik Shikshan Prasarak Mandal, Aurangabad, Samaj Bhushan Principal Rajaram Rathod, established this college in 1972. With the inspiration of Bharat Ratna Dr. Babasaheb Ambedkar, Mahatma Phule, and Rajarshi Shahu Maharaj. The infrastructure of our college is in continuous process of upgradation, and it could be noticed as one enters the campus. The college encourages and sponsors the students to participate in curricular, co-curricular, and extracurricular activities throughout the academic calendar year. Our institution, having the sports department, intercollegiate competitions, various projects, science exhibitions, industrial visits and tours, and weekly as well as twice in a month the guest lecture throughout the year. They are also exposed to barrage of information from various sources such as internet, media, and interactions with the peers. In order to emphasize the values like liberty, equality, social justice, and secularism as enshrined in the Constitution, conscious efforts are made to develop qualities of the character, courage, discipline, leadership, secular outlook, and sportsmanship with selfless service among the youth, to make them responsible citizens of the Republic of India. The motto of the college is to cater the special needs and requirements of the new entrants and those who economically were strong. We uphold the values like liberty, equality, social justice, and secularism as instinct in the Constitution. In this national webinar, we are organized here this inaugural function. In this inaugural function, Dr. Mazhar Farooqi, as a keynote speaker, contribute his valued thoughts as well as ideas amongst us. After that, in the first session, I welcome Dr. Rajesh Bhosle, sir. He is associate professor as well as head of the department in Indrashil University, Rajpur, Gujarat. In the second session, Professor Dr. Taide, sir, who is from Government Vidarbha Institute of Science and Humanities. And the topic for the technical session second, that is today's need of interdisciplinary and scientific research. In the third and last session, Dr. Bapu Shingate from Dr. Babasaheb Ambedkar Marathwada University contributes according to the contributions towards click chemistry, medicinal attributes. So friends, this is the entire schedule, and as per this schedule, the viewers as well as the thinkers are going to express here their most valued thoughts as well as ideas. Again, I will express my great gratitude that the organizer who provided me this grand opportunity to express few words pertaining to our institution, our Vasantrao Naik Mahavidyalaya, and pertaining to this one-day national ceremony. Thank you very much. Jai Hind, Jai Maharashtra.
Thank you so much, sir. I would like to give a short introduction of our chief guest, Dr. Mazhar Ahmed Farooqi, sir, Principal, Maulana Azad College, Aurangabad, who is a very prominent personality. Dr. Mazhar Ahmed Farooqi, sir, was ex-dean, Faculty of Science and Technology, Dr. Babasaheb Ambedkar Marathwada University. I would like to give a brief account of his research activities. PhD awarded to 19 students. Now, working presently are 3. He published 6 books have been published. Research publication 424. Patent awarded to UGC Minor Project 1, UGC Minor Project again 1. 3 projects are completed. He is having 30 years of teaching experiences. I request you, sir, to please give keynote address.
Honorable Chairman of today's national seminar, inaugural function, Shri Nitinji Rathod sir, Secretary Vasantrao Naik Shikshan Prasarak Mandal Aurangabad, Principal Dr. Anand Chaudhary sir, Convener Professor Jagdish Bharad sir, and all the organizing committee members. I congratulate all of you for organizing such type of a very nice activity, national level seminar, that to recent advances in chemical sciences. Sir, we know that chemical sciences is a very vast developing field of science. It covers almost entire spectrum of scientific world. Scientists are developing green synthetic methods for synthesis of organic compounds. There are bio-based and degradable polymerization reactions also going on. Scientists are also developing thermo-responsive star-shaped polymers with heteroatom type with methacrylates as one of the monomer there. Nanomaterials, nanocrystals are also of interest. For various methods has been developed to study the crystalline structure of nanomaterial and their correlation with different physicochemical parameters. There are various intermediate used. For example, an attractive approach has been devised to development of covalent inhibitors through nitriles. Bisphenol polycarbamates mimics are synthesized, which are a novel stereoisomeric lignin-derived polycarbamates. Bioorthogonal chemistry is used to develop anti-cancer drug. In a new study, researchers are using optical tweezers technology called as C-trap to investigate how different DNA repairs themselves and how they identify the damaged proteins and bind to their respective forms of damages. Apart from these, organometallics chemistry, polymerization catalyst, osmium heterocycles, hydrogenesis mimic, pi conjugated materials, then supramolecular chemistry, etc., are the frontline research areas in chemistry. The chemistry is also going to address the different types of drugs development methodologies. We are using computer-assisted retrosynthesis methods for synthesis of natural products, etc. I hereby declare that the national seminar is inaugurated, and I congratulate once again to the organizing committee as well as Vasantrao Naik College for organizing such type of a nice seminar. Thank you very much.
Thank you, sir. Thank you so much. Now I request our secretary, Nitin Rathore, sir, to address the national seminar.
Good morning to you all. Honorable Dr. Mazhar Farooqi, who has inaugurated this conference, and we are very honored that he inaugurated this conference. And our organizing committee, Dr. Bharad, who has arranged this conference for betterment of all, because today, in the backdrop of this new education policy, we should all come together and we should see the recent advances and trends in the basic sciences and what can be delivered to the students so that they are strengthened, empowered to accept the complicated challenges in the future. Our principal, Anand Chaudhary, and all the members, today, lot of emphasis is placed on basic sciences. And as chemistry is the basic branch of science, the topic of today's conference is very much relevant to the demands and needs of the society. If we want science to serve the society in better ways, we need to fulfill the requirements of the society by identifying, as suggested by the inaugurating chief guest, Dr. Mazhar Faruqi, by identifying new molecules and determine their structure so that the society is served better. And for doing this, we also need to have modern, sophisticated instrumentation techniques. This is very important because laboratories should be well equipped so that our students are exposed to the well state-of-art equipments to carry out their researches. The advancement in different areas of chemical sciences have brought in front of the society many opportunities for implementing this new educational policy. Now, friends, I personally feel this new educational policy has emphasized more on developing the thinking skills of the students rather than giving more content to the syllabus or the curriculum. And we are aware about the new structure in the education policy, that is multiple entry and multiple exit, so that various opportunities are given to the students while taking their education. And therefore, to have better design of the curriculum, we need to place more weightage on thinking skills elements in the curriculum. I personally feel like we all know Albert Einstein. He formulated the famous equation E equal to mc square. But now the light and matter interactions have brought many new insights, as we see it in the field of quantum mechanics. We all know chemistry is related in our day-to-day life, and we all know the positive side and the negative side that it is having impact on our lifestyles. So taking this as an opportunity, all the participants, I am sure they will definitely have concrete deliberations in this national seminar, and they will definitely help in solving many problems before our society and make our future life comfortable and satisfied and peaceful. I lastly thank Dr. Jagdish Bharad, who has taken so hardships to organize this seminar. And I also thank our inaugural chief guest, Dr. Mazhar Faruqi, and principal. And I hope all the participants will definitely gain and they will grow in their academics as is envisaged in our educational policy. Thank you very much and good luck for your national seminar. Thank you.
Thank you so much, sir. Thank you for taking out so much of time. I once again thank everyone for being with us. Now, I hand over the charge to Dr. Marji, sir, for the next session. Thank you so much.
Thank you very much, madam. Now we will start the technical sessions. We have Dr. Rajesh Bhosle sir from Indrashil University, Rajpur, Gujarat. I take this opportunity to introduce Dr. Rajesh Bhosle sir. Dr. Rajesh Bhosle sir pursued his PhD at the University of Geneva, Switzerland, under the supervision of Professor Stephen Matle in December 2005. Later, he moved to MIT for his postdoctoral study in the group of Professor Timothy. In April 2011, he joined the Freiburg Institute for Advanced Study, Germany, as a postdoctoral fellow, where he has been working under the supervision of Professor Maria and Professor Aurelio on the synthesis of oligomeric nitrogenated polyaromatic hydrocarbons. In March 2013, he joined the CSIR IICT as an RMIT RA fellow, where he was working on the design and synthesis of organic functional materials. In June 2015, he was promoted as a scientific pool officer and worked on functional polymers such as conducting polymers, emulsion polymers, polymer coating, and small molecules auxiliaries. Since August 2018, Dr. Rajesh Bhosle joined at Department of Chemistry, Indrashil University, Rajpur, Gujarat, as an associate professor. Currently, he serves as a head of the department and dean of School of Science. His area of research is mainly focused on the design and multi-step synthesis of functional small molecules, micromolecules, and polymers of supramolecular assemblies, chemobiosensors, and AI active bioimaging. He has published 90 articles, five book chapters, edited 3 books and 5 patents. For this brief introduction, Dr. Rajesh Bhosle, please deliver the lecture on toward the development of fluorescent material. Dr. Bhosle, sir.
Thank you, Marja sir, for giving kind introduction. Respected, can you hear me?
Yes, sir. Yes,
yeah,
sir.
And can you see the slides?
Yes, yes.
I'm sharing. Okay, just wait. Good morning, one and all. Very warm. Good morning. Respected Honorable President Rajaramji Rathod sir, Shri Nitinji Rathod sir, Secretary, today's keynote speaker Professor Farooqi sir, Principal Anand Chaudhary sir, Professor Bharat sir, and Professor Marje sir, and organizing committee. Very warm good morning to one and all. It's my great pleasure and giving me opportunity to present my research work in today's national conference, e-conference I can say. So in the just 2 minutes before, Nitinji mentioned that light and matter. So basically I am going to look the light in the chemistry. My today's presentation topic is towards the development of fluorescent light materials, which can emit fluorescence materials. So let me share you one slide where you can see the picture. This is very traditional picture. Everyone knows, but this picture gives me inspiration. This is related to the one event which has happened in the Ramayana, right? There was a war between Rama and Ravana. So during that war, several event was happened, but this event was very interesting. War between Lakshmana, the brother of Rama, and the Indrajit, the son of Ravana. So in that war, Lakshmana got unconscious with the weapon of Indrajit. So he got the weapon from Brahma, and due to that weapon in the war, Lakshmana got unconscious. So Rama was also very sad, and he said, I will leave everything. So all his soldiers, monkeys, or God, you can say Hanuman. So they were all are worried. So in that military, they had one very old soldier called Jamuanta. He suggested Rama, we have a doctor or Vaidyaraj in Ravana's Lanka, so Hanumana can bring him. So when the Vaidyaraj came here, he said, there is a medicine in the Himalaya. We have to bring that. If anyone bring that, then Lakshmana can get up, right? He is in conscious. Maybe in the morning he may die. So that was the situation. So Hanumanta was ready. Hanuman was ready to go and get the medicine from Himalaya. But the problem was Hanuman was not a doctor. He can do the job of as a courier boy, right? He is not a doctor. He cannot identify the medicine. So he asked the Vaidyaraj question, how I can identify that medicine? So here is the point. Very interesting point I found here. So what Vaidyaraj said, Hanumanta, when you go there, that time there will be, you can find a night time. Because this event happened in the night. When Hanumanta went to the Himalaya, Vaidyaraj said, when you go there, you can see there are some plants or herbs which are emitting light, right? So Hanumanta said, okay, that is the point, then I can go and get that. But when the Hanumanta went to the Himalaya and he found there are several herbs, they are shining light and then just off, means getting on and getting off, light on, light off. So Hanumanta got confused. He was not in a clue which one is the medicine. So everyone knows, then he got angry and he bring complete mountain, like we call it Drunagiri Parvat. In our Marathi language called Drunagiri Parvat. So he bring that complete Parvat. So there is the point, the medicine which are emitting light, we can call it as a Sanjeevani, Marut Sanjeevani. And that's not only one plant, there are two plants which can emit light, or we can call luminescence light, but that is for short time. They on and they get off, light on, light off. So due to that, the complete mountain was shining. So Hanumanta was not in the state to figure out which one is the medicine. So he bring the complete Drunagiri mountain and he gave to the Vaidyaraj and said, now Vaidyaraj, it's your duty to find out which one is that. So Vaidyaraj was expert. He get that medicine and give to the Lakshmana, and Lakshmana was get up before the sunshine, right? That was the story. So what inspire here? The emitting light is not like new things. It is quite old, where I can find the oldest literature in the Ramayana. So that the Sanjeevani medicine or the plant, you can say, they were the emitting light. So what mean by emitting light? Or the only that medicine is emitting light? No. There are several things when you look around. As a scientist, when you look around, there are several things which can emit lights. Like there are carnivorous plants or jellyfish or frogs or rocks. They emit light in the night with a different process. It's not like only one process. I can explain you later. What are the applications of those light? emitting light or fluorescence material. The scientists recently they developed a fluorescence light emitting mice species for the scientific purpose. It's not like a regular use, it's just for scientific purpose where they can easily find out the disease site. So they develop a completely fluorescence mice. Second application we can see, like normally people when they go restaurant, young generation or people, they have a candlelight dinner, right? So if we paint your restaurant with a fluorescent light material, you may have fluorescent light dinner. Or you can paint your kids room. So in the daytime, it can show different color, or in the night, it can show a different light emitting room, means with different emissions. Everyone, when you see this slide, Mike, and here you can see the fireflies. Everyone was excited their childhood. Why this firefly emit light? We all knows that now there is a science behind that. We know all that one. So MIT scientist, team of MIT scientist group recently, what they done, they transform the protein which is present in the firefly called luciferase protein, which is basically responsible. There is a chemical reaction happen, and that the luciferase is the protein responsible for that light emission. So MIT scientists transform that luciferase into a plant, spinach, and they made that invention is recently happened in 2020. They made a light emitting plant. Under that, you can see we can read easily. Sorry, just a minute. We can, here you can see we can read the text under the emission of that fluorescence plant. So these are the interesting things or exciting things when you look around. But how does it works? I can explain one thing, like basically I'm interested to develop a material which can emit lights. That can be useful for several applications in different fields. So what is meant by fluorescence material? Materials that after excitation by a high energy radiation, which emits electromagnetic radiation which having a lower energy beyond the thermal equilibrium. This is the kind of explanation is related to the photo emission. But photo emission is not only one event. So there are like a chemoluminescence in the chemistry. We can see there are several reactions. We can find out where light can be emitted due to the chemical reactions. Or bioluminescence, we can see in the plants, what I mentioned in the Sanjeevani medicine, the light emitting plant. Or there are electroluminescence also, which can be used for different applications like light emitting diodes, street lights, or camera flash also. How it is going to happen, this photoluminescence, how it is going to happen, the question is that one. And the answer of that question was given long back, a scientist called Jablonski. So his invention was like famous with the name of Jablonski diagram, where you can see conjugated compounds or molecules which having the electrons at ground level, when it absorb light, it get excited. Once it excited, it is not going to stay longer time at the excited state. There is several event happen. One is internal conversion, means internal conversion, and then there is this excited energy may relax in the form of vibration. If it is relaxed by vibrational, the molecule will not emit light. Okay. So while coming electron to the ground state, there are like a non-radiative and radiative elements. When it goes non-radiative process, molecule doesn't emit light. When it goes radiative process, it emits light as a fluorescence. So we can call that as a allowed transition. So molecule when excite go to the singlet state by having HNU light excitation singlet state. While coming back to the excited state to the ground state, it emits light S1 to S0. So, and then there is a, if it doesn't emit light, then it happen internal conversion or heat release. There's one more event happen. We can call it as a phosphorescence. Everyone knows it is a textbook chemistry we have seen in the BSc, in the MSc, fluorescence and phosphorescence. Phosphorescence is a forbidden state, forbidden transition we can call. Molecule goes from singlet electron, excited electron goes from singlet state to the triplet absorption state. Then triplet to the singlet, when emit light, we can call as a phosphorescence. And then there is a intersystem crossing. If it doesn't happen, it goes back. So it intersystem crossing, and that is the heat release. So when any organic compound excite, either it release energy, or we can call heat in the form of heat, in the form of fluorescence light, or both fluorescence as well as phosphorescence also, or simply phosphorescence. This is the science, or you can say mechanism behind the light emitting material. Which one? Photo emission only. I am talking only today photo emission. When you look the chromophores, there are several chromophores available in the markets and mostly used in the solution state. Here I am showing one example called fluorescein. This fluorescein is a chromophore which can emit light when it dissolves in the solution. Means when it's in the solution state and after excitation, it emits light. But if you increase the concentration of this fluorescein, or if you add bad solvent, means suppose this fluorescein is in DMSO, and if you add there some water, these fluoresceins get aggregate. Aggregation happens, so there are pi-pi stacking may form, hydrogen bonding interaction can happen. So here you can see, if there is a pi-pi interaction, these fluoresceins quench, even if you after excitation there is no emission because of the aggregation. And this fluorescein, even you can see in the solid state, there is no emission, only in the dark you can see there is no emission. It shows only kind of reddish color. Means conventional chromophores or traditional chromophores, what we are using nowadays, they are the very good chromophores or fluorophores. When they dissolve in the solution, they emit light. But if the concentration is high, or if you add a bad solvent, they get aggregate and they are not going to be emit light. So here you can see a compound fluorescein. If you dissolve in the acetone, it emits lights, right? If you increase the percentage of bad solvent from here, it's in THF, and if you increase the bad solvent, polar solvent, acetone 0% here in the first tube, fluorescein emit light. If you increase 10% acetone, still it is going to emit light, and that event happen until 50% like THF acetone. So this is well in the solution state. As we increase the more percentage of acetone, bad solvent, this fluorescein start aggregate. Once it start aggregate, it is going to lose its emission, and the losing of its emission is due to mostly pi-pi interactions or aggregate state formation. So this is the kind of limitations of conventional chromophores or traditional chromophores used in the chemistry, in biology, in physics, we can observe. So how can tackle these limitations, or how can solve these limitations? So in 2001, Chinese professor Ben Tong, he introduced one terminology called, he said, aggregation induced emission. So there are some molecules which was reported long back. So we can call this as a tetraphenyl ethylene molecule. Short form we can call TPE. Okay. When this tetraphenyl ethylene molecule dissolve in the solution, it doesn't emit light because there is a intramolecular rotation through sigma bond. You can see there is the phenyl ring get rotated through this sigma bond. Due to this rotation, it loses its conjugation. It's lose its conjugation. As soon as you add a bad solvent, or if you increase the concentration of this TPE molecule, it get aggregate and its intramolecular rotation get restrict, means rotation doesn't allow in the aggregate state. So this molecule get a longer conjugation and emit light. Here you can see in the solid state, it doesn't show any under irradiation, it shows blue emission, and in the visible light, it shows a white crystals, right? Under blue, it shows under UV radiation, it shows blue light. So this is the event. It is exactly opposite to the traditional chromophores. What he done, you can see in the experiment here. In the organic solvent, this TPE molecule doesn't show, sorry, just a minute. Oh. It doesn't show emission. Just a minute. In the first vial, you can see when the TPE molecule dissolve in organic solvent, it doesn't emit light. When you start adding water as a bad solvent, you can say till 60% of water in the THF or in the DMSO, good solvent, this TPE doesn't show emission. But if you go for more than 70%, like 70, there is a very little emission get on. If you have 80% water or it goes 90, you can see the increasing emission in the TPE molecules. That is because of only the retention of conjugation. It in the aggregate state, it restricts its rotation. You can see in the next slide, there is a mechanism how it happened. There are like, it shows two molecules. This is the TP, tetraphenyl ethylene molecule. It's called as a propeller shape molecule. When dissolved in the solution state, there is a dynamic rotation in solution. So this molecule is non-emissive. Okay. An intermediate form, their state is diphenyl methylene intermediate. When you add a bad solvent or increase its concentration, there is aggregation happen. And in that aggregation, this rotation get restrict and your aggregate will be emitting the light under the UV excitation. There is another molecule, THBA, its full form is given here at the bottom. So this molecule is like a cell-like molecule, which is also we can call luminescence, means when it get aggregate, it emits light. In the solution state, there is a active vibration and rotation in solution. So this molecule THBA is non-emissive. In the solution state, it forms ethylene tetrahedral DMP intermediate, like a radical plus charge also. When you add a bad solvent, there is this active vibrational and rotational get restrict. Vibration restriction as well as rotation restriction. So in the aggregate state, this THBA shows emission. What are the application of these AIE, aggregation induced molecules, aggregation induced emission molecules? We can call it as AIE molecules. These molecules have several applications. You can see in this picture, this molecule TPE or different Chilean molecules or different heterocycle, you can say, shown here, the structures. These molecules are very good in the aggregation induced emission state, means in the aggregate state, it shows light. What are the applications? In the biology, It used as a biological probe for biomolecular sensing, biological imaging. Also, it used as a chemical sensor, such as pH sensor, explosive gas sensor, peroxide sensor, hazardous species, or it used as a fingerprint material, chirality, viscosity, or it can use as a self-assembly material. Second, it also used as a stimuli responsive, means if you change environment, if you put force, it emits light, heat, it is heat dependent, pH dependent, vapor dependent, it shows light emission. Other optoelectronic applications such as a light emitting diode, organic field effect transistors, circular polarized luminescence material, or liquid crystals material. So these are the applications in developed in the last 20 years, I can say, after the investigation by Professor Benjamin Tong. This field was grow very fastly. Here, from this slide, I'm going to talk next 30 minutes about my work, how we are contributing in the field of fluorescence material, where we can use this material for different applications such as sensing applications or bioimaging applications. Is there any problem? Hello? Can you listen me?
Yes, sir.
Is there any problem?
No problem.
Okay, I will continue. Okay, thank you. So this slide you can see, I develop a polyurethane coating material where I mixed this pyrene, which having a trisulfate 1-hydroxy group, we can call HPTS. HPTS dye. I mixed in a polyurethane. I prepared a film for industrial application. This film gives emission in the neutral condition. When you expose this film to the acid leakage in the industry, you can see this film shows blue emission. Here we showed our film is sensitive towards the acid leakage, such as trifluoroacetic acid. Hello. Hello.
Surunshi, sir.
Hello?
Venkatesh Surunshi. Venkatesh Surunshi, please mute. Mute and mic. Venkatesh Surunshi.
Oh, yeah, Chagyo. Vishnu.
Hello. Sir, is there any?
Jaga paise ka?
Just a minute.
Yeah, let me know. I can start.
Continue, sir.
Okay. Yeah, but there is some sound coming. Yeah. Kindly please mute your mic, everyone, because I'm getting some disturbance then. Okay, thank you. We develop a polyurethane coating material with the HPTS dye. Our film, when you expose to the trifluoroacetic acid leakage in the industry, it shows blue emissions. Or our film exposed to the ammonia leakage in the industry, it shows green emission. So this is the one application. I'm not going to talk about detail of this one. Today I'm going to talk about the AI probe, which I was developed with my research scholars. And these AI active probes used for bioimaging applications. Second system we developed molecules which having a sugar moiety attached to the naphthalene diamide, or acid moiety which attached to the naphthalene diamide. So AI active NDI, we can call short form, we develop a AI active NDI amplifiers. So I will discuss only today on two topics. One is AI probe and another is AI active NDI amplifiers, which we used for self-assembly applications. When they aggregate, it shows emissions. So my whole idea is when we use the molecules, that will shows the light emissions. in the aggregate states. Okay. First, I will talk about the tetraphenethylene diol amphiphile molecules, which shows aggregation induced emissions. So I will discuss its synthesis and its shell imaging applications. And when you bind this molecule to the gold nanoparticle, so today's topic is related to the advanced technology. So here I am covering when I bind this tetraphenethylene diol amphiphile to the gold nanoparticle, its AI property get enhanced. So you can see in the slide, the synthesis is very straightforward. N-butyl lithium get proton from this active methane, diphenyl methane, generate a nucleophile, then there is an addition on carbonyl carbon, this 1-bromo-benzophenone. Okay, you get a TPE bromo. That TPE bromo undergo kind of Bookward type of reaction. It is not exactly Bookward reaction. It is a Bookward type of reaction that we done at higher temperature under pressure. So we got a TPE diol amphiphile. This TPE diol amphiphile, you can see our EI experiment. When it dissolve in the THF, you can see until 70%. If you add water molecule from first vial to this vial, where you have 70%. Okay. Oh, sorry, this is in acetonitrile. When you add water until 70%, it doesn't shows any emission. But as you add 80% water, it starts showing emission, little emission. Then there is 85% water, 90% it shows huge, means large emission under excitation, UV radiation. And at 95% it get precipitated out. It is not aggregate. You can call it as a precipitated out. So first A diagram is naked eye visualization of TPE diol. So the concentration of this molecule is 100 micromolar in acetonitrile. In the first on all vials, it is 100 micromolar in THF. Only thing difference is we are going to increase addition of water in the percentage. B, spectra B, here you can see this is a emission spectra, or we can say fluorescence spectra. So the intensity of fluorescence we measured on fluorescence spectrometer, you can see until around like 80% of this molecule in the acetonitrile, it doesn't emit light. As we see, it start from 80, it shows little increase in the emission, 85, this blue curve. Then you can see this 95 black, and the red one is the 90. 90 is the highest emission. So here you can see the linearity as the water fraction goes increase from 0 to 80. So there is no emission. As 80% water, there is start emission, 85, 90, and 95. So our molecule, our TPE diol amphiphile molecule shows highest emission at 95% water, where molecule get well aggregate and shows highest emission. Second experiment we also done in THF, and we like here it mentions, sorry, in DMSO and water. You can see naked eye visualization in DMSO and water. In the DMSO, our molecule start emission from 70%, means in the DMSO water mixture, this molecule get aggregate at 70%, start from aggregation at 70%, and it increase. No, there is no any precipitation. At 95%, you can see the highest emission intensity. So what we done, we provide our molecule to our collaborator, biology collaborators. What he done, he used our molecule for cell imaging purpose, especially for cancer cell imaging. So here you can see our TPE diol molecule. It enters in the cell and visualize the cell. Even its precursor, TPE bromine, the first step molecule, that's also able to emit the cell imaging, show the cell imaging applications, right? And there, this is the well-known dye, they call UT dye. As a reference they use. And with reference, we can see our molecule is very good enough to show cell imaging applications. And here the bottom spectra you can see TP diol 100 micromolar, or when you increase the concentration of TP diol molecule, it shows at 250 micromolar, it shows highest intensity. TPBr less intensity compared to the TP diol, and TPBr if you go to 250, it decreases intensity. As you bind our TP diol molecule to the gold nanoparticle, you can see the concentration of increasing our molecule, and this is the increasing the fluorescence intensity after binding to the gold nanoparticle. This is the linearity where you can calculate the binding constant. Standard curve of attached TP diol with the AU gold nanoparticles, and that nanoparticle used for cell imaging, where you can see this blue dots is the highest emission in the cell. It shows blue emission into the cell. So due to the binding to the gold nanoparticle, it enhances its emission. Our next molecule is, we can call tetraphenylethylene phosphonate based aggregation induced emission material. So here we synthesize our phosphonate TP molecule and use as a cell imaging applications. This molecule is very good to visualize cell membrane. So its synthesis starts from dihydroxybenzophenone. Okay, we first Williamson etherification, and then this coupling reactions. Condition is given here. TiCl4 zinc reflex, we get TP, tetrabromo TP. This tetrabromo TP treated with triethyl phosphonate 130 degrees Celsius. We in 48 hours we get this tetraphosphonate TPE molecule. This molecule also shows aggregation induced emission. When you increase water percentage in the DMSO, it starts emission at 70%. So first diagram is naked eye visualization of TPE, our 4 tetra phosphonate group binded molecule, 100 micromolar concentration in DMSO. First while it doesn't show, even second at 50% water and DMSO it doesn't show, 60% water DMSO it doesn't show any emission, but from 70% water it goes start increasing the emission, which are the highest emission from 90 to 99%. At neutral pH, means water in the sense we add here PBS buffer. Under UV visible spectroscopy, we can see, under fluorescence spectroscopy, we characterize our molecule. Here you can see the spectra. As we increase the buffer, PBS buffer in water percentage, at 50% it shows very, very little, means nothing. So 60% very minor. As it goes 70%, it goes 70 to 80%, it starts emission, which can be found by spectroscopy characterization. At 90%, 99%, it shows highest emission. Here, this is the linearity. If you increase the percentage of PBS buffer, our molecule get aggregate start from 60 and have highest emission around 90%, 99% water molecule. This one we used for visualize a cell. So in comparison with DAPI, this is the control molecule, DAPI dye. Generally, this cell imaging people or biological people, they use the DAPI dye to visualize cell. And this is our tetraphosphonate TP molecule. This molecule is very good enough to show cell membrane, nucleus cell membrane. And when the bottom series is the merged. When you merge, first you can treat with DAPI that goes into the cell nucleus. Our molecule is very well to visualize cell wall, and when you overlap, you can see the difference. So our molecule, the green emission is coming from our TP tetraphosphonate molecules. So this experiment done on HeLa cells, fluorescence images of HeLa cells. This experiment actually done by our collaborators. Here, I can give the credit of this excellent result to our collaborators' efforts. So next one is, we also develop a TP molecule which are bearing of 4 pyridine units. We can call it as a tetraphenylethylene pyridine based aggregation induced molecules. We have synthesized this molecule and utilize to see the change in the pH, to see the cellular pH, or to detect the cellular pH, or monitor the change in the pH in the cell. The synthesis starts from this benzophenone. The similar reaction using TiCl4 zinc pyridine, you get this TP. Then there is a bromination reactions, very straightforward reactions. We will have tetrabromo. Then there is Suzuki reactions using boronic acid pyridine, 4 boronic acid pyridine. We get this tetraphenylethylene 4 pyridine unit conjugated molecules we can call TPE4PY. This molecule is very well studied in different solvents. You can see in the chloroform, methanol, and DMF, our tetrapyridine molecule TP doesn't emit any light. Okay, when it get protonate, this the nitrogen of pyridine ring get protonate and it start emit. But its emission you can find in the chloroform. That event we characterized by fluorescence spectrometer. Here you can see at 440 nanometer, our this tetrapyridine TP molecule emit light. But when it get treated with acid TFA, it shows emission, high emission at around 534 nanometer spectrum, means emission shifted toward the right hand side. This molecule we utilize for visualize different pH into the cell. You can see the first column is control, the blue channel and green channel study. At pH 3, the cellular pH is 3. When cellular pH is 3, our TP molecule which having a 4 pyridine ring are able to emit the green fluorescence. When the pH is neutral, means around 7 or basic 9, our pyridine molecule is good enough to emit a blue emission. So it means we develop bioprobes which can be selectively find out the pH of cell. If it is acidic pH in the cell, it shows green emission. When it is neutral or basic, it shows a blue emission. So here I'm summarizing the TP related work. We develop amphiphile molecules which we used for bioimaging probe that get aggregate, and in the aggregation is in the form of cubicle, which can be further bind to the gold nanoparticle and utilized for cell imaging applications. We develop a TP molecule which having a 4 phosphonate group attached to it, which can be used for cell imaging applications such as nucleus shell wall imaging, which shows aggregation. The aggregate is in the form of like a needle shape structure, which can be characterized by fluorescence spectroscopy. We develop a TP molecule which having a pyridine units that can be used for selectively sensing the cellular pH. So next topic is I'm going to talk about NDI, naphthalene diimide related work. Here basically what I done, naphthalene diimide I conjugated with sugar molecules, carbohydrate we can say, by click chemistry. In the last session, I think Dr. Bapu Shinte is going to talk about the applications of click chemistry in the medicinal. But I would like to say that here we utilize that click chemistry to conjugate sugar molecule and our naphthalene diimide molecules. And that we utilize for shelf assembly, which can be emit lights. Synthesis is very straightforward. Here you can see sugar molecule. Okay. This protected sugar molecule, which having a azide unit. which undergoes deprotection, means deacetylation we done and get the D sugar. We can call this as a protected sugar, and this is a deprotected sugar. It's hydroxy group free or protected. So this sugar unit we use further to conjugate with our naphthalene diamide. Here we naphthalene diamide synthesize, where one side we can have this acetylene, which is utilized for click chemistry. When it couple with what it undergoes click chemistry with this deprotected sugar, we can have a naphthalene diamide amphiphile which is having a free sugar, means hydroxy group. Or when the protected sugar couple with this NDI which having acetylene, we can have a NDI amphiphile. Here the hydroxy group is protected with acetate group. So both things we used, both molecules we use where you have protected sugar or deprotected sugar. You can see this is the UV visible spectroscopy absorption. Our naphthalene diamide shows characteristic 3 absorption peaks. You can see this 1 and 2 and 3. So this one is at 382 nanometer, or the second one is 364 nanometer. When you increase the water percentage in the solution of NDI, which having the protected sugar, it get aggregate. So aggregation you can see at 0% water, it shows very well absorption peaks. But when you start aggregation, addition of water, it get aggregates, and further at a higher water percentage, it get flattened. So that same trend we can observe in the deprotected also. Deprotected sugar naphthalene diamide amphiphile that we characterized. Now this is the cyclic CD spectroscopy data we can call, and this is very interesting data. When we have protected sugar, from the CD spectroscopy we can understand the cotton effect, positive cotton effect or negative cotton effect, means our molecule is having any chirality or not. Okay. This one where we observed our molecule shows self-assembled chirality. Okay, from this solution, from this study. So CD spectroscopy shows that our protected molecule has absorption. You can see this above the plane, right? But addition of water at blue, when you have 50% water, where it's in DMSO, pure DMSO, it doesn't shows any cotton effect. Protected NDI, when it goes 50% water, it shows highest cotton effect. 90%, it shows still positive effect. At 99%, it shows kind of flatten or little bit negative cotton effect. When it goes deprotected sugar molecule NDA amphiphile, it shows reverse cotton effect. When you have 50% water, it has a absorption peak. It shows absorption peak or below the plane. At 0% water, there is no any cotton effect. But at the 50%, 90% and 99%, our NDI shows cotton effect, negative cotton effect. Okay, what it mean by, what is its application? I can show in the next slide. So first, we done the EIA study on the fluorescence spectrometer. So you can see this is the absorption. This is the emission of our molecule when it is in the pure organic solvent. When you start adding the water molecule, it get quenched and forming at highest water concentration. Around it starts from more than 50% water. It starts from forming a new peak. We can call that as an aggregation induced emission peak that we observe at right hand, means it shifted to the right hand side, forming a new peak. So that we plotted here, water versus emission. So you can clearly see until around 50 to 60%, there is no any AI effect we can see. But once you start more than 60%, this molecule start emission. So in the vial, you can say in the insert, you can see in the organic solvent, it doesn't emit any light, but in the water mixture around 99% water, it shows bluish green. emission. And this data, first data is related to our protected molecules, means sugar molecule was when it is protected, means the sugar molecule protected amphiphile shows this EI effect. What about the deprotected sugar molecule? Deprotected sugar molecule doesn't show that much EI effect. It shows but minor EI effect when you go for when you do the study under the fluorescence spectroscopy study, but we cannot see that substantial increase in the emission. Here, either increase, it shows decreasing the emission, but not that much. Here you can see concentration study we done. When we increase the concentration of molecule, okay, its emission going to increase. And when you increase the water ratio, when you increase the water at 50%, at 50 micromolar, it shows the decrease of emission. So out of these two amphiphiles, naphthalene diamide, which are having a sugar molecule protected by acetate, those molecules, protected molecules, shows only aggregation induced emission. And very interestingly, you can see a naphthalene diamide sugar molecule with protected shows aggregation like a rod-like shape. Okay, when we look the aggregation of naphthalene diamide sugar molecule where the hydroxy group is open, it shows particle-like nano assemblies. Or when you go for protected, it shows rod-like assembly. What is the difference? Why it shows like that? There is a role of this, there is a role of that open hydroxy group and protected hydroxy group. In the protected case, there is that molecule is hydrophobic in nature. It doesn't form like a particle size, particle-like nature. Here in the inset, you can say in the cartoon, we try to put the hypothesis how it get form a rod-shaped structure, or when the sugar is deprotected, it shows nanoparticle-like structure. My next assembly is tartaric acid. I attach the tartaric acid with naphthalene diamide, but in the tartaric acid there are two hydroxy groups. So I used here same strategy. What the strategy? Either hydroxy group is protected or deprotected. So what I done? I synthesized tartaric acid, attached NDI amphiphiles, and their aggregation induced supramolecular self-assembly, their chirality study, and photophysical properties. So the synthesis is very straightforward. You can see we made this naphthalene diamide. This naphthalene diamide is treated with this anhydride, which is going to open. Okay, just treatment with amine and this anhydride, you can see this open, which is the hydroxy group is protected. And this hydroxy group we further simply deprotected and have a free hydroxy group. So these two molecules we utilize to study the EI study or to check the supramolecular self-assembly. So we can call first as a NDI-TA, NDI tartaric acid, which is having a protection. Hydroxy group get protected. And second one is NDI-TA1, where hydroxy group is open, means there is no any protection. So this spectra shows, you can see the first one is absorption spectra of our molecule NDI-TA, where the sugar molecule get protected. So in this case, in the THF, when we add methyl cyclohexane, bad solvent, our molecule get aggregates. Hello. Our molecule get aggregates. And the same study we done under the fluorescence spectroscopy, we can see with increasing percentage of methyl cyclohexane, this protected NDI-TA hydroxy protected molecule shows emission on at like 95%, 90 to 95% MCH in THF. Our NDI-TA amphiphile shows high emission. That we can see in this diagram C, where increasing fraction of MCH, methyl cyclohexane in THF, around 70 to 80% MCH, our molecule start getting emission. Okay, that study also we checked, means formation of which kind of aggregate we checked by CD spectroscopy. And here you can find when we go for 10 to 90, this is the SCM, scanning electron microscope images of naphthalene diamide NDI-TA. So what we done here, 10 to 10% THF and 90% MCH, you can see. So this our self assembly molecule form a fiber like structure which is having a helical nature, this helical nature. Okay, and another molecule means the deprotected molecule, which having a sugar hydroxy group deprotected molecule, which shows like caterpillar like structure or worm like structure we can call, but that at 30% THF and 70% MCH. So THF MCH volume ratio increases. You can see this is the zoom picture of this C diagram, and B is the zoom picture of diagram A. So where you can see clearly the twist that we can find by CD spectroscopy, which can show the Quaternion effect when it get aggregate. Okay, until the very good soluble state, it doesn't show any Quaternion effect. But when you start aggregation from above 70% of water, it shows a Quaternion effect. It means of forming a supramolecular helical structure that was proved by SCM images, where you can see the forming a fiber-like structure which having a helix nature, and the NDI amphiphile molecule which having hydroxy group open, that shows a caterpillar like a structure. Here I'm going to summarize. My work. We develop two types of naphthalene diamide amphiphils. One is having a sugar molecule, another is having a tartaric acid molecule. Our sugar molecule shows when it is protected EI state, and in the tartaric acid case also, when it is in the protected state, it shows EI aggregation induced emission. So the whole talk what I deliver today is related to the molecules when they get aggregate, means in the solid state you can say, or when they have high concentration in organic solvent, or if you add bad solvent, we can call bad solvent. In the organic solvent, it get aggregate and it's emit light. So with this, I would like to thanks for giving attention towards my lecture and listening my lecture. I'm happy to answer if there is any questions. Thank you very much.
Thank you very much, Dr. Rajesh Bhosle, sir. This session is open for discussion. If you have any questions, you have to ask. First, you have to unmute yourself and ask the question. Yes, Ajay Kumar, sir.
Hello. Thank you, sir. My question is to Rajesh Bhosle, sir.
Yes,
sir. Will you please go to your 20 number slide? 20
just wait.
I have very basic questions regarding that. Extremely sorry if it is
20 number, right? Okay.
Yes, sir. So here only in pi TPE molecule, what is so special with the proteination of that pyridine nitrogen that make it fluorescent there, and that too in only chloroform like polar molecule? That was my question.
The special means when it get when you excite molecules, if it is having kind of lone pair of electron, it is going to quench your excited status also. What we are doing when we protect, when you protonate pyridine, so this molecule is losing its lone pair of electron, isn't it? So there is no lone pair of electron is available for quenching effect. So that we observe here. That is the first thing. And another thing is when it get protonate, it doesn't solubilize that much in the, it is like a salt form. Okay, it doesn't solubilize in the chloroform. But you know, in the polar solvent like methanol and DMF, it gets solubilized very well. So I believe that is the reason behind that.
Okay, okay. But sir, chloroform is also enough polar solvent that can solubilize.
What I found compared to the DMF and methanol, chloroform is not that much polar solvent.
Okay.
That's in 3 solvent we do the study, and we found in DMF, if you see DMF is highly polar, then the comes down is methanol and then chloroform. You go for polarity ways. So we found this when it is in the salt form, means when in the protonate state, our molecule, it is get kind of aggregate in the chloroform and it start emitting. But in the methanol and DMF, it is still in the very good solution state. So it means when it's in the solution state, it starts rotating and losing its conjugation. I believe that is the answer behind that.
But sir, anyway, the lone pair on nitrogen is not involved in conjugation.
Yeah. But no, why it is not emissive in the methanol and DMF? That the mechanism I told you. No, TPE molecules, when it's in the good solution stage, their phenyl ring starts rotation. Okay. But in the chloroform, that rotation gets strict because of the aggregation. That is the one reason.
Okay. Yes, sir. Thank you, sir. Thank you.
Okay, thank you, sir.
Sir,
Yes, anybody? Shivraj Sirsad, sir. Sirsad, sir, if you have questions, you can ask. Otherwise, you mute your mic.
Or you can type your questions. I will try to give answer if you can type also.
sir, I'm audible, sir.
Yeah.
Sir, this protonation step is only for the solubility matter or any more?
Sorry, what is the question?
This protonation step
is
only for solubility matter?
Sir, there are two things when I mention about the mechanism of these special EI molecules, right? So one thing is, sir, when you look my left hand side, this molecule is very soluble in the all 3 solvents. Okay. And when it goes for protonation, it forms kind of like a plus charge. I can say it is a salt state, and it start aggregate in the chloroform. But methanol and DMFs are very good solvent. They are enough to be solubilized that salt. That's why the molecule is not emissive in the methanol and DMF. But in the chloroform state, it is very good. We can say aggregation.
Okay, anybody?
Yeah, if there is no question, then I will ask you one question. Everyone. Marje sir.
Yes, sir.
Can I ask question?
Why not?
Yeah. If you listen my first slide, I try to be extract that that Ramayana story. Hello. Yeah, I tried to be extract Ramayana story and found that Sanjeevani medicine is a issue. What could be still I'm not sure what kind of emission is there. Either it's like bioluminescence or any other kind of luminescence. It is like hypothesis. I made kind of hypothesis because I belong from one small town like that place in the Latur district. And in my old days, in each village having this Ramayana storytelling and reading. So there was kind of one-day conference happening in every villages we can call Shakti. मराठीत आपण त्याला म्हणतो ना शक्ती लागली. तो शक्तीचा प्रोग्राम व्हायचा प्रत्येक गावामध्ये. Right?
Yes, sir.
त्यावेळेस मी ती स्टोरी ऐकली होती. नंतर मी ट्राय केलं की फाइंड आउट द ओल्डेस्ट लिटरेचर वेअर वी कॅन फाइंड द emission properties. So I found this is the interesting. So I believe that is the bioluminescence, but someone can comment on that if it is maybe different way. It is for audience also all.
Sir, we think it's a bioluminescence.
It is bioimaging, bioluminescence.
Yeah,
right?
because
Okay.
chemical reaction takes place in the plant.
Yeah.
Yeah.
But can you believe, sir, that is the oldest literature we have related to the bioluminescence material, isn't it? Or is there any old literature we can find such kind of, we can see like bioluminescence or bioemission we can find? I found only this one in the Ramayana. Okay, is there any question on research topic?
Okay, sir. Thank you very much, sir.
Okay.
Dr. Rajesh Bhosle has delivered a lecture on toward the development of fluorescent material, a very simple language. Definitely, these lectures will be beneficial for our participants. On the behalf of management, principal, and Department of Chemistry, Vasantrao Naik Mahavidyalaya Aurangabad, I am very much thankful to deliver this very nice lectures. Thank you, sir.
Thank you. Thank you very much, Marji.
Now let's move toward the second session. Now for this second session, we have a very eminent personality from Amravati regions, Dr. Deepak. Sirsat sir, you okay? Very prominent personality from the Amravati regions, Dr. Deepak Taide sirs. Deepak Taide sir is from Government Vidarbha College, Amravati. Under his able guidance, 27 PhD students are completed PhD, 13 students completed MPhil degree. To his credit, Dr. Taide sir published 208 papers in national and international journals. He gives a keynote address more than 15. He published 13 books, and other than chemistry, he published 9 books. If you see the administrative experience, he is a nodal officer, coordinator of different committees. Dr. Taide sir has awards, that is teaching faculty awards from the Innovative Excellence, then Sahitya Alankar, Mahanubhav Grantotsav, Uttejak Awards, Dr. Babasaheb Ambedkar Research Awards. He is a Best Teachers Awards from GSBS Mumbai. He has completed 2 projects, and we know that this Aurangabad regions, Amravati region, then whole Maratha regions were known personality. Dr. Tukaram Taide sirs, not wasting my times, I would like to invite Dr. Deepak Taide sirs to deliver the lectures on today need interdisciplinary and scientific research. Dr. Taide sir.
Good afternoon to researcher, various faculties, and my friends. I, Deepak Taide, congratulate to organizing committee of National Seminar on recent advances in chemical sciences and technology of Vasantrao Naik Mahavidyalaya Aurangabad on the occasion of Golden Jubilee of this college. Friends, Dr. Bhosle sir delivered a very good lecture, and after my lecture, my dear friend, my younger brother, Dr. Bapu Shinte is going to deliver his beautiful lecture on click chemistry. Friends, whether I am audible? Hello?
Yes, sir. Yes, sir. You are audible.
Whether, can you see my screen?
Yes, sir.
Yes, sir. Yes, sir.
Okay, thank you, thank you. Friends, as these two stalwarts are going to deliver their lectures on various topics, so I am going to discuss with you on the general research. That is, how will you carry out the research, how you can work in research, how you design the research scheme, and what should be your research topic. So I give the title for this lecture as today's need of interdisciplinary and scientific research. Why you want to carry out the research? Dear friends, in the last week I discussed with dear Bapu Shinte that Bapu, when we carry out our research, then that research is only our passion. It is passion. We carry out our research because we are not getting the service on the basis of research. It is not essential thing. It is not a status symbol, or it is not needed for the promotion in the service. So at that time, generally the researcher carried out their research work under the noble teachers, noble guide, noble supervisor, because those researchers as well as supervisors have their passions in the research. Nowadays, again, various researchers in organic, physical, analytical, such types of research, there are various researchers who carried out their good research work in your region. Dr. Bapu Shinte, Dr. Bara, Dr. Mazhar Faruqi, Dr. Retired principal from your college, Dr. Milind Ubade, Sayed. Means this research team is very good research team. From the BAMO, there is again good research carried out. But as a researcher, I think this research should not be carried out for getting service, for getting status, or for getting promotions in the service. Research must be passion in your mind. What is research? It is called as research. Means that thing is already present in the nature. You have to discover it, not investigate. In the last year, the Nobel Prize is given on the click chemistry. What is click chemistry? Bapu will describe in detail in his next session. Research is the systematic investigation of the study material sources in order to establish fact and research new conclusion. Means that process, that compound or that principle is already existing in the nature. Nature is the giant laboratory. Nature is the giant laboratory. Research is an endeavor to discover new or to collect old facts. That is by the scientific study of the subject or by the course of the crime. We may already think we know the answer to our questions already. We may think the answer is obvious, common, and sensible. Research is the systematic process of collecting and analyzing information data in order to increase our understanding of the phenomenon about which we can consult or interested. Dear friends, during designing the scheme, you have to create interest, or you may interest in particular topic. Our research may be interdisciplinary, or may be subjective, or may be specific. Means there are some organic chemists who are interested in to design different types of compounds for the human being. In the click chemistry or in the some good laboratories or the institute, the compounds are designed or the materials which are designed is useful to the society. Each and every research has its own importance. When we consider the importance of the research, then that research must possess high quality research. Good research require the scope and limitations of the work to be clearly defined. Means during the performing or during the designing the scheme of research, your prediction or your definition and your scope of the research must be clear. There should not be problem in the research. The process to be clearly explained so that it can reproduce and verified by other researchers. In our research, it is observed that particular researcher carried out one scheme, suppose, but when he published his research paper, then the original process or procedure is hidden in that paper. Means there may be some misunderstanding or loopholes, or that researcher or supervisor or that fellow is not interested to open his work. Dear friends, in my research journey, near about, I started my research from 1985. In my research journey, I am come on this decision. When you explore your research, the different types of schemes were seen. मैं आप लोगों को देखो हिंदी में एक बात बताना चाहता हूं. जब मैंने एमएससी किया, मैंने पहले ही बताया है आपको कि एमएससी करते वक्त हमारे दिमाग में ऐसा कुछ भी नहीं था कि अपने को ये करना है, वो करना है, वो करना है, बस रिसर्च करना है. क्योंकि हमारे जो गुरुजी थे, डॉक्टर परांजपे सर, ही इज फ्रॉम बीएचयू, डॉक्टर एमजी परांजपे, ही इज फ्रॉम बीएचयू. तो सर के दिमाग में एक ऐसा पैशन था कि अपन ने ऐसा करना चाहिए, अपन ने ऐसा करना चाहिए. क्योंकि उस वक्त जो हरगोविंद सिंह खुराना जी है, उनको हमारे इज इंडियन बाय बर्थ, तो उनको नोबेल प्राइज मिला था. सर के दिमाग में वो सब बैठा था, हमारे वो पैशन था उस वक्त कि अपन ने भी कुछ सोसाइटी के लिए करना चाहिए. तो जब हम स्टूडेंट थे, तो स्टूडेंट होते वक्त ही उन्होंने हमारे दिमाग में डाल दिया कि आपको रिसर्च करना है. हमारे जो काफी बैचमेट है वो साइंटिस्ट एफ तक पहुंचे, साइंटिस्ट 20 से लेके साइंटिस्ट एफ तक. तो सर के दिमाग में हमारी जो रिसर्च टीम थी, आई वाज 28th नंबर. उस वक्त ऐसी लिमिटेशन नहीं थी कि इतने स्टूडेंट रहेंगे, इतने स्टूडेंट रहेंगे. एमएससी होने के बाद तुरंत हमने रिसर्च शुरू की. रिसर्च करते वक्त हम एक एफिलिएटेड कॉलेज में हमारा सिलेक्शन हो गया. सिलेक्शन होने के बाद थोड़ा सा सब्जेक्ट में हमारे टीचर की वजह से हमारा सब्जेक्ट थोड़ा बहुत अच्छा था. तालुका प्लेस का कॉलेज, वहां पे हमारा नाम हो गया. नाम होने के बाद वहां पे मेरा स्पेशलाइजेशन, उस वक्त स्पेशलाइजेशन रहता था, ऑर्गेनिक केमिस्ट्री स्पेशलाइजेशन था. ऑर्गेनिक के और उस वक्त ऐसे 3 डिफरेंट पेपर थे, ऑर्गेनिक, इनऑर्गेनिक और फिजिकल. तो ऑर्गेनिक के हम क्लासेस लेते रहे, टीचिंग हमारा ऑर्गेनिक का रहा. बाद में उस वक्त ऐसे ट्यूशन को वगैरह ऐसी बंदी नहीं थी, हमारी सैलरी बहुत कम थी उस वक्त प्रोफेसर लोगों की. उस वक्त एक कहावत थी, मागायचं नसेल भीक तर मास्तर पिशी, यानी नेक्स्ट टू लेबर और नेक्स्ट टू भिखारी टीचर की पोजीशन थी समाज में. तो इसलिए ट्यूशन अच्छी चलती थी, ट्यूशन अच्छी खासी चलती थी. हम ऑर्गेनिक भी पढ़ाते थे. ऑर्गेनिक की हम ट्यूशन नहीं लेते थे क्योंकि क्लास में हम पढ़ाते थे. फिर फिजिकल हम पढ़ाते थे, इनऑर्गेनिक की ट्यूशन लेते थे. तो हमें ऐसा लगता था कि अपन बहुत अच्छे टीचर. और उस वक्त उम्र भी हमारी ज्यादा नहीं थी. आई एम जस्ट 24 year old. At the age of 24, I get appointment as a lecturer. उस वक्त लेक्चरर ही पोस्ट. तो उस वक्त ऐसा लगता था कि अपन बहुत होशियार है, ऐसे हवा में उड़ते थे। गेस्ट लेक्चर देने जाते थे हम, मुंबई, पुणे यूनिवर्सिटी, औरंगाबाद भी आ चुके हैं, और बाकी के डिफरेंट कॉलेज में, हमारी यूनिवर्सिटी नागपुर यूनिवर्सिटी में जाया करते थे। तो हमें लगता था अपन केमिस्ट्री में बहुत होशियार है, बहुत होशियार है। उस वक्त हमारे गुरु जी के आशीर्वाद से हमारा रिसर्च भी अच्छा था। हमें ऐसा लगता था कि अपन रिसर्च बहुत अच्छे है, अपन बहुत बढ़िया टीचर है। लेकिन जब मैंने मेरे अंडर स्टूडेंट थे 1992 और मैंने एक्चुअली मेरा रिसर्च शुरू किया, जब रिसर्च शुरू किया उस वक्त में हमारे ध्यान में आया कि एक थाई यूरिया, ये यूरिया का अपन ऐसा बोलेंगे कि चचेरा भाई है, थाई यूरिया पे हमने एमएससी में भी काम किया, थाई यूरिया में हमने पीएचडी पे भी काम किया, और नियर अबाउट 57 स्टूडेंट थाई यूरिया में अमरावती, नागपुर और गोंडवाना यूनिवर्सिटी से पीएचडी ले चुके। तो बताने का मतलब एक ही है कि जब हम बोलते कि हम ऑर्गेनिक केमिस्ट है, हम फिजिकल केमिस्ट है, आई एम एनालिटिकल केमिस्ट, आई एम इनऑर्गेनिक केमिस्ट। अरे बाबा, ऑर्गेनिक केमिस्ट में इतने सारे करोड़ों मॉलिक्यूल्स है। देखो यहाँ पे स्टूडेंट भी ज्वाइन है, मैंने कल वराड़ सर से बात की, तो आप लोगों को बताना चाहता हूं मैं कि इतने करोड़ों मॉलिक्यूल्स है ऑर्गेनिक केमिस्ट्री में, और एक साल में काफी मॉलिक्यूल तैयार, काफी मॉलिक्यूल, न्यू मॉलिक्यूल विल बी इंट्रोड्यूस इन द ऑर्गेनिक केमिस्ट्री। उसमें का एक ही मॉलिक्यूल है थाई यूरिया, जो थाई यूरिया पे मैंने नियर अबाउट 57 स्टूडेंट ओपन किए। यानी एक दरवाजा अपन खोलते हैं रिसर्च का, तो 100 खिड़की, 100 दरवाजे और 100 वेंटिलेटर खुल जाते जब अपन रिसर्च में वो डायरेक्शन से। इसलिए मैंने ये टॉपिक लिया है क्योंकि मुझे मालूम था कि शिंटे सर और भोसले सर उनके पर्टिकुलर टॉपिक पे बताएंगे, इसलिए आई एम टॉकिंग ऑन जनरल। मीन्स व्हेन वी ओपन वन स्कीम, then 100 doors, 100 window, 100 ventilators are open. And when we enter from one ventilator, then we found that there are 1000 ventilator, 1000 doors and 1000 windows. So in this slide, I clearly mentioned the process to clearly explain so that it can reproduce and verify by other researchers. अभी हमारे रिसर्च में ऐसा होगा कि अपन रिसर्च शेयर करेंगे भाई, तो कोई उसको चुरा लेगा, ठीक है, हुआ है। दिस थिंग वाज हैपन इन द डॉटर ऑफ मादम, मींस देयर इज अ ऑब्जेक्शन ऑन द बोर्स थ्योरी एट दैट टाइम। Now we are not interested to discuss that topic. Means when we carry out the research, it must be particular. There should be limitations for the particular topic. Means we must focus all details in all corners of the molecule. Data to be adequate and analyzed and explained. All findings to be presented clearly, and all the conclusions must be justified with sufficient detail. Means if we synthesize, suppose one compound in organic or complexes, then in that case you must study its ultraviolet property, its IR, NMR, mass, XRD, C30, H. Means all study for the determination and justification of the compound must be carried out by the researcher. He is that true researcher. If some peaks or signals are missing, or extra peaks or signals are there in our spectrum, then why those peak or peak signals are there in the signal? It must be justified. It must be clarified. Means no any other misunderstanding or miswriting should be included in your research paper, or there should not be some loophole in the spectrum. Means when we want to carry out a research or a design research scheme, that a research scheme must be scientific research, consist of seeing what everyone else has been seen and put, but what no else has thought. It means that you have to design, means someone carry out his research work on physical study of that company. In physical study, in our lecture, we see this topic in the next slide. Next slide. When we want to carry out our research work, your research work should not be specific. It must be interdisciplinary research, and it must be scientific research. In most of the research, actual significances and importance of the research are not studied. Means suppose I am an organic chemist. I only synthesize organic chemist or organic compounds, prepare 2 to 3 schemes, near about 50 to 60 compounds, and I submit my thesis. But what is the use of the synthesized compound to the society? Means you synthesize particular molecules and see its all applications. You describe its all application. Means actual significances and importance of the synthesized compound of your research must be studied. So, in such research is not treated as applied research, means you perform your research or you synthesize some types of compound and you didn't carry out its applications or importance, then that research is not called as applied research. Your research must be applied and it must be useful to the society. Your research is not only for getting the promotion or only for getting the service or only getting the status in the society. Applications of the research is not known to the researcher who carried out. Means, now I am sorry to say, what are the applications? Why we are choosing this topic? Why, how, and what? This is research. Means you first consider during designing the scheme, means there are some supervisors. Why you perform? देखो भाई बाबा आदम के जमाने से रिसर्च चल रहा है इसलिए हम कर रहे हैं, नहीं, उन्होंने किया ठीक है, मैं ये क्यों कर रहा? Why I am carrying this research? Whether this research is applicable to the society or human being, or if in some research it is observed that means some supervisor performs such type of reaction conditions that they develop new reaction conditions for the already reported reactions. Means their approach is toward the green chemistry. We the chemist are responsible to create much more pollution in the environment. Means during our research, design such reaction scheme which are environmental protecting or eco-friendly reaction. My one research group carried out such types of reaction. They performed the research in which they are using the green solvent. In some reaction conditions, we are not using these types of solvent. We are using the different types of juices from the natural sources, that is plant. In most of the research in chemistry, it is observed that organic chemists synthesize organic molecules. Inorganic chemists synthesize complexes. Physical chemists carried out physical study of the synthesized compound. And here they stop their research. In interdisciplinary research, there should be one team, organic and inorganic. One means one or two members will perform the synthesis of the compound. 2 or 3 physical chemists will study their physical properties. The microbiologist carried out antimicrobial and medicinal studies. And the biochemistry people should perform the pharmacokinetics and pharmacodynamics of that particular synthesized compound. Means this is the teamwork. Means when you want to carry out the good research, there should be collaboration in between these types of people. So before 5 to 10 minutes, I discussed with you that there should not be hidden research. Means organic chemist or inorganic chemist synthesize organic compounds or nanoparticles or complexes. And after that, they will make collaboration with physical chemists and carry out and study the physical properties of this compound. These physical properties, physical study in viscometric measurement, conductometric measurement, interferometric measurement, refractometric measurement of these compounds with different concentration, different temperature, different organic solvent will be studied. And after that study, you can theoretically report the pharmacokinetics and thermodynamics of that particular synthesized organic compound or complexes or nanoparticles. Means you can predict how that synthesized compound is useful. Suppose you are synthesizing anti-inflammatory drug. What is the action of that drug? In my university, I am teaching medicinal chemistry. One paper in MSc, 4th sem, 3rd sem and 4th sem. Means drug activity, drug effect. The prediction of drug activity and drug effect, that is metabolic activities of that compound, synthesized compound, will be predicted on the basis of these physical study, physical measurement. That is conductometric, viscometric, interferometric, and refractometric. You can say that this drug is useful, this drug is better. Means that is your prediction. And whether the compound is active, biologically active, what are the physiological actions, anatomical actions, biological actions, can be described with the help of antimicrobial activity on the basis of result of physical measurements. Next, please. Organic and inorganic chemistry. The duty of the organic chemist as well as inorganic chemist is to design more efficient, novel, convenient and easy process for the synthesis in which reduce or eliminate the use or generation of hazardous substances. Means we have to design the new research scheme which are eco-friendly. Because the chemist must think on global warming. And what is the impact of your research on the environmental parameters? Scientifically, your research must be sound, cost-effective, and least toward the sustainable civilization. This is the first priority of the chemist. In designing process, there must be waste minimization at the sources, use of catalyst in the place of reagent. Many workers from your university, Bamu University, and from our universities are working on such scheme. Using non-toxic reagent. Means during my research work, I carried out my reaction and synthesize compound by using acetone and benzene. But my research student replaced that acetone and benzene. And 2 students who are working as assistant professor in Nagpur and Amravati University replace organic solvent. They use natural fruit juice. Means we are moving toward eco-friendly reaction. Means in our research, during designing the research, the supervisor as well as student think use of renewable resources, improve atom efficiency, use of solvent-free or recyclable. When I discuss with my young researcher or some supervisor in various universities, it is observed that they are performing microwave reactions or ultrasonic reactions. But whether, no doubt, these are solvent-free reactions. But whether it is applicable to the society, means whether it is my question is that whether it is applicable to the society. It means that during designing your research scheme, it is applicability of your research must be first. Those reactions must be environmentally being solvent and system. Preventing pollution before it happens rather than cleaning up the mess later. Means this must be considered by the researcher. Environmentally being solvent system means your synthesis must be one-point synthesis, all solvent-free synthesis. Use of catalyst means this is the best solution. Use of the catalyst opens new path in the synthetic chemistry, but much more problem. Means it take much more time. The student of synthesis and many research are carried out their research work by using different types of catalyst or solvent. From last 2 decades, we are working on the environmental being solvent systems in the organic synthesis. In this synthesis, a new environmental being solvent systems will be investigated, in which time span of the reactions reduced by increasing the yield of product and maintaining the purity. During such synthesis, green chemistry parameters were maintained. Means friends, when I was a research student in 85, then for the synthesis of compound, starting compound, I required 18 hours continuous heating, reflection in acetone. But when I work out on this research, then I told to my student, dear friends, reduce this span and try to replace the acetone. And in 7th batch, I got fruitful result. Means you must maintain patience during research scheme. Dear friends, I am giving one example. We develop environmentally being solvent system for the synthesis of one substrate, 3,4-pyrimidinothiocarbamides in ethanol acetone media. I told you that this reaction was carried out by me when I am student. This is a simple reaction. Means cyanopyridine is treated with substitute thiourea in acetone. When I registered my first student, then I told him that I am using acetone. I want to replace this acetone. And in 3rd batch, we replace ethanol also. Means we didn't use the organic solvent for this simple synthesis. This is simple synthesis. This synthesis was carried out by the Halls. Here, when I carried out this research work, then there is a acetone. Purely I use acetone. But the yield was poor. When my research student carried out the combination of ethanol acetone, then we decrease the time span as well as we increase the yield of the product. See, in this method, first, when we carry out this reaction in acetone, the time span is 16 hours and yield is 67. In ethanol, this reaction was not performed. In benzene, time span is 18 hours and yield is only 48%. In carbon tetrachloride, again the time is 18 hours, 48%. Ethanol acetone, we here study the percentage of ethanol. And here we find out when the percentage is 60%, that is 60% ethanol and 40% acetone, then the time span is reduced, that is 2 hours, and the yield is 90. Means after my research, my 4 students are working on the same type of reactions. Then they develop new reaction conditions. Means this type of reactions are in eco-friendly or environmental friendly reactions. Means you have to design your research scheme like this one. Because this is research. Means already that work is carried out by anyone. Why carry out the antimicrobial activity study? It provides, means after the title of my topic is that you must perform today's need of research is that you have to perform interdisciplinary work. Means this is the teamwork. After synthesis of this compound, means the prior duty, I say that the prior duty of the supervisor as well as researcher or student is that to design eco-friendly or environmental reactions. And after that, don't stop this. Hand over your compound or in collaboration or with these microbiologists or such labs are there. You carry out its medicinal properties, biological properties. Whether the synthesized compounds are useful to the human being, useful to the society. When we carry out the antimicrobial, don't think, no sir, I carry out antimicrobial. Yes, you carry out antimicrobial activity, but whether you carry out the couplet method, after that MIC method, minimum inhibition method. And after that, whether you carried out those study on the different concentration mode, means your research work must be like a research. Because your result will provide medicinal as well as pharmaceutical applications and significances of the synthesized molecule. After synthetic work, carry out the antimicrobial study, that is couplet method and MIC method. This study gives the information whether the synthesized molecule possesses medicinal values, and we can conclude whether it is used as precaution. Why we determine the physical parameter? This physical parameter provide information of pharmacokinetics and pharmacodynamics of the molecule. Means when we want to study the drug effect or drug activity, there are 4 steps involved in the pharmacodynamics of the drug. Means first there is a drug absorption, second step is drug diffusion, that is transmission. In some books or in some papers, you find out that there is a drug transmission. And the third step is drug metabolism. In drug metabolism, the drug activity and drug effect will be. And fourth one is drug excision. You can take drug by 2 methods, by orally or by injection. When you want to study these 2, that is drug absorption and drug diffusion, that is drug transmission. In that case, the drug absorption means before taking that drug or before prescribing that drug, the stability of the drug will be studied. And the stability of the drug will be studied on the basis of potentiometry and spectrophotometry. On the basis of potentiometric study as well as spectrophotometry, means cross verification of that stability constant and such factors. Dr. Jagirdar is from your university. His contribution in physical chemistry is so vast. I am organic chemist trained, but I salute to his work. Dr. Jagirdar, Dr. Narwade. These are the product of your government. Means the stability of that drug will be described on the basis of potentiometry and spectrophotometric measurements. These results provide us the stability of drug. After the stability of the drug means when you take that drug, it must be stable in your stomach, in your esophagus, because there is acidic condition. Means the stability constant of the drug or of that molecule at different molar concentration, different reaction conditions will be studied, and this study will be done on the basis of potentiometry and spectrophotometry. After that, that drug is absorbed and transmitted. That is drug diffusion. Means diffusion in blood, first absorption. Means when that drug is absorbed or diffused, this study give a prediction of the diffusion of drug and absorption of drug will be done on the conductometric, viscometric, and interferometric. In this study, viscometric, particularly in viscometric and interferometric study, the solute-solvent interaction, here the solute is drug, solute is drug, and solvent is water. And in water, because that drug is diffused in the blood, and through that blood it will be circulated throughout the body. Means in this case, that drug must be stable. Again here, potentiometric as well as spectrophotometric result will define their stability in the blood. So when that drug is absorbed or when that drug is diffused, throughout the body, there should not be chemical solute-solvent interaction or solute-solute interaction, because there are different types of constituent in the blood. It should not create solute-solvent interaction or solute-solute interaction. This measurement was given. The prediction of this will be done on the basis of viscometric, conductometric, and interferometric. Means this is the useful. Physical chemist results are useful for this. In drug metabolism, there is a drug activity and drug effect. Actual drug effect means here enzyme. How that enzyme will interfere during drug activity and drug effect. These two parameters will be studied in the drug metabolism and drug excretion. After all, the drug byproduct or excess drug will be eliminated out through urine. Means this is total various steps involved in pharmacodynamics of the drug. Means for this, we are interested to carry out the interdisciplinary research. Which types of physical parameters I have already described during that process. That is pH metric measurement, spectrophotometric measurement. This measurement describe the stability constant, that is stability. These parameters, these results are useful for determining the stability of the drug. Conductometric measurement, viscometric measurement, refractometric measurement, and interferometric measurement. These measurements are useful for predicting theoretical. Means this is the theoretical. Computational chemistry is the theoretical chemistry research. Means we get the exact theoretical result. This type of study provide information of pharmacokinetics and pharmacodynamics of the synthesized molecule, and we can conclude whether this drug is useful or not. Means so this type of research work is useful for the organic chemist as well as inorganic chemist. I have already described these parameters. Why spectrophotometric measurement? In spectrophotometric measurement, we determine the stability constant and conformation of the complex formation in the solution. It provides information of the stability and formation of complexes, structural reactivity and analytical applications of the metal ion and gas. These values give information, rate of passing of drug through the cell membrane, biological and pharmacological activities. Means absorption and diffusion. Stability as well as absorption and diffusion of the drug, particular drug, synthesized drug. The prediction of these parameters will be done by this spectrophotometric and potentiometric study. Stability and formation of the complex are hampered by interference of hydrogen bonding, protic-aprotic, polarity, nature, and dielectric constant of the solvent. Nature of metal ions, that is nuclear charge, ionic radius, size of metal ions, oxidation number, effective nuclear charges, electronegativity, and from the above fact, variations in the log K values and stability complex and conditional stability constant can be determined, which is used, which justify the activity of the particular drug or particular compound. Why viscometric measurement? It is very simple, safe and easy to handle. All types of pharmaceutical and physical parameters can be determined. Less amount of sample is required and molecular weight can be determined easily by this viscometric measurement. And in viscometric measurement, I have already told you that in pharmacokinetics, we want to study the drug absorption, drug diffusion, drug metabolism. And these parameters will theoretically explained with the help of viscometric measurement. Means with the help of this viscometric measurement, you can find out the solute-solvent interaction, solute-solute and solvent interaction, solvent-solvent and solute interaction. These measurements are useful to determine the rate of passing of the drug through cell membrane. Through cell membrane. What we determine in the viscometric measurement, that is Falcon coefficient and Johnson-Dole coefficient values, and the thermodynamic parameter, that is Gibbs free energy, standard enthalpy and standard entropy, can be determined. And the correlation in between the drug activity and viscosity is useful to study drug receptor interaction. So I am interested to carry out the interdisciplinary work, and I am telling you that you must carry out the interdisciplinary work. Means viscometric, when we consider the viscometric measurement study, this viscometric measurement study is useful in pharmaceutical chemistry, in synthetic and drug chemistry, in synthetic and drug chemistry. Previous one. Sorry, friends. Means viscometric measurement is useful for the agricultural purpose. Means on the basis of these measurements, which I have told you, these viscometric measurements are useful in the industrial, biotechnological, medicinal, pharmaceutical, synthetic and drug chemistry, synthetic and drug chemistry, and biotechnology. Means these are the applications of viscometric measurements. Refractometric measurement means when you carry out, means I told you that when you perform the potentiometric measurements, the cross verification of the potentiometric result will be studied by spectrophotometry. Here the refractometric measurement as well as viscometric measurement go hand in hand. Means I will not waste your time. Then in conductometry, why you want to carry out the conductometric measurement? Applicable to very dilute solution. Means our focus in the research is that to synthesize nano drug, and after nano drug, the minimum amount of drug should be required to cure that particular disease or stop the growth of particular pathogens. And this study require minimum, or this study can be done on very dilute solution. Required minimum amount of chemicals, all types of pharmaceutical and physical parameters can be determined. Means two-step in drug activity. That is diffusion, absorption and diffusion. These two processes will be studied with the help of conductometric measurement. Means this is the theoretical prediction. Give accurate result. In conductometric result, there will not be error. Here we get the accurate result, easy to handle and safe to handle. Why we determine these parameters? Conductometric parameter, again, we can justify these types of parameters with the help of conductometric measurements. That is solute-solvent interaction, solute-solvent interaction, dipole association. Means there should not be physical or chemical interaction in between the solute, that is drug, and solvent, that is blood or water in the human being. So these parameters are essential for the drug activities. Means we must study the polarity, dielectric constant, dipole moment, intermolecular interaction between solute and solvent. This type of study can be done with the help of conductometric measurement. This is the site. Now, applications of conductometric measurement is that to study the molecule formation, molecule formation, and these types of study will be determined in the drug chemistry, and so conductometric study is much more useful. From conductometric measurement, the observed conductance, specific conductance, molar conductance values can be determined. Specific constant, that is Ksp, log Ksp, and thermodynamic parameters which change in the free energy, that is delta G, change in the entropy and change in the enthalpy can be determined at various molar concentration. And why this is essential in drug chemistry? Because the side effect of that particular drug will be determined on this. That is delta H, delta G, delta S. Means these factors are responsible for the side effect of drug. Means on theoretical paper, you can determine whether this drug shows the side effect, less side effect, and here you can make suggestion to your organic chemist or inorganic chemist, substitute such type of drug. Make substitution on that particular nucleus, that it will decreases or reduce the demerits or side effect of that particular drug. Means this suggestion will be given with the help of this conductometric measurement, viscometric measurement. That is, you substitute the electron withdrawing group, bulky group, aromatic group, nitro group, chloro group. What organic chemists do? Organic chemists synthesize such type of compounds in which they only prepare analog or derivative of the previous and study their activity. That activity will be studied by in biochemistry or in some different laboratories. Means this type of suggestion, whether electron withdrawing group or electron donating group should be substituted there. What should be molecular weight? This calculation can be done with the help of conductometric measurement. Again, this is the summary of my conductometric study. Then in interferometric measurement, again, It requires minimum amount of chemical, all types of pharmaceutical, physical parameters can be determined. Give accurate result. Again, this is the beauty of this interferometric measurement, that is ultrasonic study. In this study, conductometric and interferometric measurement, we get accurate result, easy to handle and safe to handle. Means this is the beauty. Why we need interferometric measurement? In interferometric measurement, we determine the dielectric constant solute solvent interaction. Here in this study, Professor Naik is my physical chemist friend, who is working in a university chemical tech department, and he is a best chemical physical chemist from this region. In collaboration with Dr. Naik, I carried out this research for physical tech research. Means here solute-solvent interaction, solute-solute-solvent interaction, dipole association, solute-solvent-solvent interaction, polarity and mutual compensation of that. These are again important factors for the drug activity and justification for the drug activity and drug effect. So here we carry out the ultrasonic velocity trial. In this measurement, we carry out the acoustic thermodynamic parameters, that is adiabatic compressibility, apparent molar compressibility, apparent molar volume, intermolecular free length, relative association, and specific acoustic independence. The acoustic parameters are useful for predicting the pharmacodynamics of any drug, any drug. So from last 2 decades, the organic chemists make collaboration with such physical chemists. And the work which I have described or I have discussed with you, I carried out such interdisciplinary work in my laboratory. Some of my student, MSc student also, project fellow student, recently prepared the nanoparticles. Nanoparticles, eco-friendly nanoparticles from different types of juice or plant extract. And they dope the different types of metal in that particular juice. The characterization of the compound was carried out. We get satisfactory result. And here we find the medicinal properties of that particular plant or that particular herb or shrub or fruit. And then we carried out the medicinal applications of these synthesized nanoparticles. Here we get good and satisfactory result for antioxidant property. I carried out anti-inflammatory activity of that particular synthesized nanoparticles as well as. Now these samples are sent to the for screening of anti-cancer activities of that particular nanoparticle. Means 5 students are working. 5 students are working on this project. Means as an organic chemist, some students purely synthesize organic compound. Near about 1,000 or more than 1,000 organic compounds are synthesized in my laboratory. During synthesis, we develop new types of reaction conditions. The main motto of my research is that our reaction should be eco-friendly. I prepare different types of complexes. At the same time, I carried out all types of measurement and prediction of the compound. I make collaboration with physical chemist, pharmacy, types of activity. Humble request to all faculties, super lover to carry out the interdisciplinary work collaboration. The Earth's innovate must take a look at the research, energy resources, conservation. It is the first priority of the Now we are entering in the centenary year. Started by English people. In organize our new research. This is my the researchers. These are my research students. Internet will upload it. I am thankful, particularly Principal Dr. Bharat, Organizing Secretary, IPSC Coordinator, Principal, Management, to receive constructive suggestion and query. Thank you very much. Hopes of good tomorrow. Research for all and for your patience.
Thank you, sir. This session is open for discussion. If you have any questions regarding this lecture, you can ask from audience. Anybody from audience? Okay. Thank you very much, sir. Dr. D.T. Dadi sir has delivered very nice lectures on interdisciplinary and scientific research. Definitely, sir. Today, the need of this interdisciplinary and scientific research, this lectures will be beneficial for participants. On the behalf of management, principal, and Department of Chemistry, Vasantrao Naik Mahavidyalaya Aurangabad, I am very much thankful for delivering this very nice lecture. Thank you, sir. Now let's move to the third sessions of this national seminar. I am here to introduce Dr. Bapu Singte sir. Dr. Bapu Singte sir is a very prominent and ground to earth lecturer from this area. His qualification is MSc, PhD, NET, GRF, SET. Dr. Babu Singte pursues his PhD from NCL, National Chemical Laboratory. It is affiliated to the Savitribai Phule Pune University. Later he joined the Department of Chemistry, Dr. Babasaheb Ambedkar Maratha University as an assistant professor. He has a 15-year teaching experience and more than 20-year research experience. During his teaching journey, he got teacher awards in 2018, Indian Society of Chemists and Biologists, Lucknow. He is a brand ambassador of Bentham Science Publishers. He got Research Professors Award and Ideal Teacher Award from Dr. Babasaheb Ambedkar Maratha University. He got Indo-US Research Fellowship Award. He got the Shikshan Pratibha Puraskar from Dr. Babasaheb Ambedkar Maratha University. Up to he has delivered more than 60 invited talks in national and international conferences, seminar, and symposium. He delivered lectures as a resource person in refresher and orientation also. He given a guest lectures in various universities, more than 60. Under his able guidance, 4 students are pursued a PhD degree and working as 6 students. He is a reviewer of more than 40 journals, that is Nature Scientific Reports, Journal of Medicinal Chemistry, Synthetic Communications, Chinese Journal of Chemistry, Ultrasonications. To his credit, more than 100 publications in national and international journals. We all eager to listen to Dr. Babu Sinte sirs. For this brief introductions, I would like to invite Dr. Babu Sinte sirs to deliver the lectures on contribution towards click chemistry, medical attributes. Dr. Babu Sinte sir.
Am I audible, Marges sir?
Yes, sir, you are audible.
Very good afternoon to one and all. First of all, I would like to congratulate Vasantrao Naik College Aurangabad. Now it's Chhatrapati Sambhajinagar. Organize this national seminar on recent advances in chemical sciences and technology. I am very much thankful to the principal, convener, Professor Jagdish Bharat sir, organizing secretary, Dr. Balaji Marje, and all the organizing committee members who have invited me in this particular national level seminar. As rightly mentioned by Dr. Bharat sir in his introductory remarks about the objectives of organizing such kind of national seminar on recent advances in chemical sciences and technology, as we have entered in the third decade of 21st century, and as per the UGC UGC have made mandate to us to adopt new education policy 2020. And in future, as well as earlier also, because of this COVID-19 pandemic, we have witnessed that the effectiveness of online teaching learning program. And definitely each and every teacher as well as a student will take the benefit of such kind of online programs. And one of the important thing mentioned by the secretary of this Vasantrao Naik College, Rathore sir, about the significance of advances in basic sciences and identification of new molecules and their new applications, as well as our keynote speaker, Dr. Mazhar Farooqi sir, have given brief idea about the young generation of the researchers. What kind of areas of research one has to focus. And he has mentioned in his keynote address, the use of green chemistry, biodegradable polymers, nanomaterials, and their physicochemical parameters, polymer chemistry, sustainable chemistry, and many more areas he has focused. As well as he has also mentioned one of the area of research in 21st century, definitely bioorthogonal chemistry. And for this concept, Professor Caroline Bartrozzi have received a Nobel Prize for the year 2022. Thanks to Dr. Farooqi sir, and I will enlighten that point also over here, bioorthogonal chemistry. And later on, one of the speaker, our friend from Indrashil University, Dr. Rajesh Bhosle sir, he has given excellent topic to the audience, like fluorescence. And later on, our senior teacher, mentor, Dr. Tayade sir, have discussed about the significance of interdisciplinary research. Just I will add over there, not only interdisciplinary, but our focus should be multidisciplinary. Okay, not within the discipline, but beyond the discipline, we have to perform our research. And definitely he has enlightened very good concepts in chemistry, design, synthesis, physical property studies, then physical study, then various kinds of properties. It may be theoretical properties, therapeutic properties, or some other. And his main focus was on how to adopt the concept of green chemistry for sustainable future or sustainable development. And Dr. Tade sir's focus was on one of the parameter which have been used in a drug design and drug development or drug discovery process. That is the pharmacokinetic and pharmacodynamic properties of the molecules or drugs or materials. It may be inorganic material also. And his main focus was on ADME properties. It's nothing but adsorption, distribution, metabolism, and excretion. And use of various instrumentation techniques. Yeah, that is very much important because the students as well as teachers are performing several experiments on basic instruments like spectrophotometer, polarimeter, conductometer, etc. And Dr. Tade sir has highlighted how to utilize such kind of small instruments in research as well as some theoretical calculations. With this, just for the sake of introductory part, I have highlighted earlier presenters' work, and now here I am very much thankful to Dr. Balaji Madje sir, who has given a nice introduction and invitation too. Now, today I have chosen the topic contribution towards click chemistry, and the title of this particular talk seminar is Recent Advances in Chemical Sciences or Allied Sciences also. And in addition to that, there is the one word technology. And we all have learned the new technology of delivering talk through online mode. That is a technology. And I am taking the advantage of that technology over here. Sir, Madje sir, my presentation is visible.
Yes, sir. Your presentation is visible.
Just 1 minute, sir. Just, I will make it in PowerPoint mode.
Yeah.
See, the today's topic is contribution towards chemistry. Contribution towards click chemistry, and my focus is on click chemistry. And in addition to that, medicinal attributes or medicinal significance, or we can call it a pharmacological significance of the synthesized molecules via click chemistry approach. But prior to that, we will consider some of the important aspects why people are entering in the field of medicinal chemistry. As rightly mentioned by Dr. Tade sir, and Tade sir have made my job very easy now, because he has discussed almost all aspects of drug discovery and drug development process. As we know, in India, there are different causes of death in India, different causes. But I have considered over here very few causes, and it will start from heart disease. See, as we all have witnessed that so many people are suffering from heart attack or blockages in their heart. And because of that heart attack, lot of deaths occur in India. See, amongst 10,000, 1% is suffering from heart attack, and definitely it goes to the death. That is the first cause of death in India, and this is a major cause, we can say. Then another cause of death in India, that is a chronic obstructive pulmonary. Means many more people are suffering from chronic diseases. Acute disease as well as a chronic disease. And because of this chronic obstructive pulmonary disease, many more people are getting death because of this particular cause. And in the rainy season, in earlier days, not only in earlier days, but also in 21st century, many more people are suffering from diarrhea. And because of this diarrhea, no doubt there are some drugs which can cure this particular diarrhea. But if it is at the last stage, then the person can go for death also. Then brain stroke. See, this is one of the causes in India. In earlier days, the number of the people are suffering from brain stroke was very less. But we have seen in 21st century, many more people have died because of brain stroke. And they are entering in coma. And after a few days, 2 days, 3 days, 4 days, or 10 days in coma, finally doctors are suggesting to the family members of that particular patient, your patient will not cure. And if you are ready to donate some of the organs to the patients, and the patient can survive because of this particular brain stroke patient. And we have seen that the organs like a kidney, the organs like a liver, the organs like eyes, as well as the skin, means many more organs can be donated. Many more organs can be donated. And see, in the month of March, 9th March, the whole world is celebrating World Kidney Day. And on that day, the whole world is celebrating World Kidney Day. And that day, the doctors or the organizations are felicitating to the people, those who have donated their organs. See, this is one of the awareness just I have shared with you. Then later on, one of the cause, lower respiratory infections. In Corona, we have seen the problem of respiration. The problem of respiration. And because of that respiration problems, many more people have died. And that cause may happen because of that coronavirus. Okay. Then one of the important disease in India, that is a tuberculosis, TB. And in rural places, not only in rural places, but also in towns also, many more people are suffering from the tuberculosis. Okay. In addition to this tuberculosis, neonatal preterm birth means we have seen that the birth of either child in the form of son or daughter, before the completion of 9 months, many mothers are giving the birth to the child in the month of 7th or 8th. And that child is facing some kind of problems later on. Okay, that's why neonatal preterm birth, because of this one, many more deaths occurred in India. Then one of the cause of death in India, self-harm. See, one of the picture just I have shown over here, self-harm, just one of the picture. Then many more self-harms are there. And because of self-harm, in newspaper also, we are reading several self-harm cases every day in newspaper. Okay, in only one district, every day, around 10 people causing death because of self-harm. And the most important cause of death in India, that is the road injuries. See, again, more than 10% newspaper is covering such kind of accident every day. And that is one of the cause in India, as well as other neonatal conditions. Around 10 causes of death I have covered over here. In addition to this, we have witnessed that several flus, because of those flus, for example, swine flu, we have seen just 4 to 5 years before, 10 years before, many more people have died because of that swine flu. And later on, some drug came in the market, that is the Tamiflu. Not only flu, but also different kinds of infections. See, in this month or last month, many more people have suffered from various kinds of infections. Not only in the month of January, February, December, but also in rainy seasons also, a lot of infected people we have seen. It may be bacterial infection, it may be fungal infections. Not only those infections, but also in 2020 to 2022, we have seen one of the disease or one of the virus, that is the coronavirus. And in India, we have seen that many more people have died because of that coronavirus, COVID-19. First phase, second phase, third phase. And these are some of the causes of death in India. not only just representative causes of death in India, I have shared with you. As I have mentioned that one of the causes of death in India because of tuberculosis, and my focus is on tuberculosis. See, this tuberculosis, the patient will suffer by means of TB, tuberculosis, and it is spread through Mycobacterium tuberculosis. These are some Mycobacterium tuberculosis, and the patient, those who are suffering from TB, these are the signs. The person or the patient will suffer from fever, lot of fever, night sweats, cough, as well as the chest pain, weight loss, loss of appetites, as well as fatigue. These are the symptoms of the tuberculosis. Okay, not only these symptoms, but also some additional symptoms are also there. And the patient who is suffering from tuberculosis, from his mouth, it can be transferred to this particular bacteria. Okay, tuberculosis transmitted from the person via droplets from the lungs of people with active TB. No doubt, there are several vaccinations are available in the market to prevent tuberculosis. Okay, the person who faces the problem of tuberculosis can be affected by means of some other diseases also, in addition to TB, that is a diabetes. Or some of the persons, they may have a TB as well as a HIV, both. Okay. And this TB can be occurred because of continuous smoking, as we are calling it, chain smoker. Okay, see, no doubt there are some vaccines, there are some drugs available in the market to cure the tuberculosis. And you may have seen the persons, those who are facing the problem of tuberculosis, such kind of skin you may have seen, or such kind of signs on the patient, on the leg of the patients, those who are suffering from TB. See, as per the WHO, World Health Organization, tuberculosis is one of the top 10 causes of death worldwide. Not only in India, but also worldwide. This is the top 10 cause of death worldwide. And see the data for 2015. 10.4 million people fell ill. 10.4 million people fell ill with a TB, and 1.8 million people died from the disease. Means around 20% people, those who are suffering from the tuberculosis, were died in the year of 2015. And see, over 95% of TB death occurs in low and middle income countries. And 6 countries, about 60% of the total, with India leading the count. Means in India, you will see majority of the patients, those who are suffering from tuberculosis. Followed by Indonesia, China, Nigeria, Pakistan, and South Africa. See, means 2 subcontinents, two continents are facing the problems of tuberculosis. One is Asia and another one is the African continents. In Asia, particularly India, Pakistan, and China. Okay, India, Pakistan, and China, the majority of the peoples are from these 3 countries, and out of those, India is a leading. India is a leading. Okay, and this is alarm for the peoples, those who are staying in these countries. No doubt, there is a vaccine, there is a drug. But there is a scope to the young generation from the chemistry, from the microbiology, from the biotechnology, bioinformatics, chemoinformatics, and medicine field. They can start work on how to prevent tuberculosis. And see, as I said that there are several drugs, medicaments available in the market. Just I will tell you, the first drug was discovered to cure or to treat a TB was para-aminosalicylic acid. It's a very small drug. And there is no need. See, you can see the drugs which are available in the market. If you go through the structures of those drugs, they are very small drugs. Even though you can take the example of aspirin, it's a very small drug. It's nothing but oocyl derivative of salicylic acid. Very small drug. But even though today that aspirin is described by the patients to cure respective disease. See, this para-aminosalicylic acid in 1943. And later on, Waxman and School discovered streptomycin, and this streptomycin antibiotic, which has made remarkable progress in the treatment of tuberculosis. Later on, in 1946, thiacetazone, and in 1952, this isoniazid drug came in the market. And till today, even though after 70 years also, the doctors are recommending this particular drug, isoniazid. And later on, in the year of 1952, pyrazinamide, again, it is a pyrazine base, and this isoniazid, it is a pyridine base drug. In 1952, pyrazinamide, and in 1957, this rifampicin drug came in the market. And these two drugs has totally changed the strategy of the chemotherapy, those who are suffering from the tuberculosis. And later on, again, small molecule, that is ethambutol in 1961. And then some quinoline-based drug, that is a fluoroquinolones, which is a newer macrolide and the conjure of rifampicin. Even though today, see this isoniazid, pyrazinamide, rifampicin, as well as ethambutol, doctors are prescribing the combination of these four drugs. If the patient is at primary stage, combination of such kind of drugs which are anti-tubercular drugs. Now just I have given the names of the drugs and I will show you the structures, because I heard that from the organizers there are several undergraduate students as well as postgraduate students. And I have to take care of those undergraduate as well as postgraduate students. In addition to that, budding researchers are also there. Okay, and I will show you the structures of those drugs, but prior to that, the drugs which are first line drugs, that is isoniazid, rifampicin, ethambutol, pyrazinamide, and streptomycin, these are the first line drugs. Then these are the second line, and the newer second line drugs, that is ciprofloxacin, ofloxacin, levofloxacin, clarithromycin, and azithromycin. No doubt they are the antibiotics. And these antibiotics are 4th generation, 5th generation, 6th generation antibiotics are there. But till today, there are several drawbacks of such kind of drugs, as Dr. Thayde sir has rightly mentioned about the drawbacks of such kind of drugs. Okay, and I will show you the structures of isoniazid. See, this is the drug, which is the skeleton, that is a pyridine, and this is the acid hydrazide moiety. And see, the position of that acid hydrazide moiety is at 4th position. The position of the substituent or the functional group is very much important in drug discovery process. Okay, as Thayde sir mentioned about the donating and withdrawing group, presence of donating and withdrawing group on the structure, on the molecule. Not only presence of electron donating and withdrawing group, but the position of those groups is also important. Okay, if you take the substitution at 3rd position, that compound is not active, nicotinic acid hydrazide. That compound is not active. It never acts as a anti-tubercular agent. See, this pyrazinamide, pyrazine-based structure is there, and amide. Ofloxacin, kanamycin, rifampicin. See, this ethambutol, it is nothing but 1,2-amino alcohol is there. And this 1,2-amino alcohol is, see, this ethambutol, as we belongs to Aurangabad, and one of the organization in Aurangabad research center, that is Wakad Research Center, they have developed this particular drug ethambutol long back. And till today, it is a working for the treatment of ethambutol as a combination of the drug. That is isoniazid, pyrazinamide, ethambutol, and rifampicin. Okay, no doubt, this is a new drug. This is a new drug which is a quinoline skeleton. Quinoline skeleton, and the name of this drug is a bedaquiline. And as per the expert from the medicine field, they are suggesting that this particular drug can survive with the patient, those who are suffering from TB for next 10 years. For next 10 years, this drug can be used for the treatment of tuberculosis. My dear friends, participants, and colleagues, the people, those who are suffering from primary level tuberculosis, definitely it can be cured. And it can be cured within 1 year, within 6 months of the treatment of such kind of drugs as well as the vaccines. Those who are suffering from the multi-drug resistance tuberculosis, MDR TB, multi-drug resistant tuberculosis, then it requires 1 year to treat that TB patient because they are not responding most of the drugs. That's why it came under multi-drug resistance tuberculosis. And the last stage, that is the total drug resistance, or XDR, we can call it, means they are not responding to any kind of drugs which have been recommended for the treatment of TB. That is the total drug resistance. And definitely that kind of patients are facing the last stage of TB. Okay. Now, another disease, one of the important disease, that is about a fungal infection. And you may have seen the people, those who are suffering from such kind of infection on their eyes, on their hands, on their legs, or on their this back, or on their heads. This is a superficial fungal infection like a ringworm, and this is occurred on skin and mucus of the membrane. Okay, this is a one kind of fungal infection. And another type of fungal infection is called as a systematic fungal infection. Okay, and which is occurred by the fungi, that is Candida albicans, and which is an opportunistic infection. And you may have seen the people, those who are having such kind of infections on their neck or on their tongue also. Okay, this is a systematic fungal infection. And to treat such kind of fungal infection, there are several drugs available in the market. Several drugs. So many antibiotics are there, like amphotericin B, nystatin, and griseofulvin, just representative drugs I have shown over here. There are azole antifungals are also there. For example, ketoconazole, albendazole. So many drugs are there, azole antifungals. Allylamines, terbinafine, pyrimidine base, that is a flucytosine, and this is a very small drug which is used for the treatment of fungal infections. Okay. As majority of the people's researchers from the organic chemistry, they are focusing on design and development of azole antifungals. And there are two types of azole antifungals are there. Two types, as per the presence of number of nitrogen atoms, as well as the ring size also. Okay, these azoles are synthetic compounds. They are not a natural products. No? They are synthetic. And basically two types of azoles are there. One is imidazole base, which is having a 2 nitrogen atoms. It may be at 1,2 position or 1,3 position. 1,2 imidazole or 1,3 imidazole. Sorry, 1,3 imidazoles. 1,2 it becomes pyrazole. This is triazoles. Again, two types of triazoles are there. It is a 1,2,4 triazole and 1,2,3 triazole group of antifungal drugs which inhibit the enzyme of cytochrome P450 14 alpha demethylase. And this enzyme converts llanosterol to ergosterol via 14 alpha demethylation process. If you go to the structure of llanosterol to ergosterol or to cholesterol demethylation, demethylation of 14 alpha methyl group, and that is required in fungal cell membrane synthesis. And these drugs also block steroid synthesis in human. And now, as I mentioned that there are two types of azole antifungals. One is imidazole base and another one is a triazole base. And in imidazole base, iconazole, ketoconazole, chlorotrimazole, isoconazole, and many more imidazole based antifungal agents are there. And these are triazoles. Again, two types of triazoles, as I mentioned, 1,2,4 and 1,2,3. And here there are 1,2,4 triazoles. All are 1,2,4 triazoles, means the position of nitrogens in the 5-membered ring. That is a 1,2,4 position. And these triazoles are newer, less toxic, and more effective, like fluconazole, itraconazole, rauconazole, voriconazole. These are the or posaconazole. These are the 1,2,4 triazoles, and they are less toxic and highly effective. And almost all these triazole-based drugs are available in the market. See, I will show you the structures of these 1,2,4 triazoles. See, the position of the nitrogen is at this 1, 2, and 4 in fluconazole. In voriconazole, again 1, 2, 4 position. In itraconazole, again 2 triazole cores are there. Here triazole and here triazolol. Again, it is at 1, 2, 4 position. Same one. No doubt, there are many more triazole-based drugs are there available in the market. Okay. And in addition to this, just I want to share with you, in the month of October, on the day 5th, you may have seen or you may have heard about the Nobel Prize in Chemistry for the year 2022. These 3 great chemists, 2 from USA and 1 from Denmark, have received a Nobel Prize for their contribution in the field of or in the development of click chemistry. As Dr. Bhosle sir, Rajesh Bhosle sir, have a little bit explored this particular concept for the development of click chemistry and bioorthogonal chemistry. And they are nothing but Professor Caroline Bertrozzi from Stanford University, USA, Professor Morten Meldal from University of Copenhagen, Denmark, and Professor K. Barry Sharpless from Scripps Research Institute, USA. These two professors from USA, and both are from same state, that is California state. Okay, and this Professor Morten Meldal from Denmark. See, I will tell you a little bit about this particular concept of click chemistry as well as the concept of bioorthogonal chemistry. Mr. Navnath Jadhav, either you have to mute your audio, videos. Yeah. See, Professor Caroline Bertrozzi, Professor Meldal, and Professor Sharpless, KB Sharpless, have received a Nobel Prize for the development of click chemistry and bioorthogonal chemistry. And Professor Sharpless have coined this term click chemistry in the year 2001. And parallelly, Professor Meldal have also worked on the same concept, but Professor Sharpless have given the name for that particular concept. Okay, see, Sharpless have coined the concept click chemistry. Meldal came up with a special chemical structure called triazole. And meantime, Professor Bertrozzi took the next step of developing click reactions that could work inside the living organisms. See, Miss, it is the combination, and Dr. Tayade sir have mentioned about interdisciplinary, but I should consider multidisciplinary. Okay, Professor Bertrozzi have started working on development of this click reaction in the living system, and termed as Professor Bertrozzi have termed this particular bioorthogonal reaction or bioorthogonal chemistry. And they have brought chemistry into the era of functionalism. Sometimes people are saying that click reaction have changed the chemistry. See, this is a click reaction. How it changed the concept of chemistry. How it changed the concept of chemistry. See, concept of chemistry. And what are the findings of research these two people have made, Professor Sharpless and Professor Melder? See, in 2000 around, because Sharpless have published his first contribution in the year of 2001. And prior to that, Professor Sharpless have developed this click chemistry concept. It is nothing but combination of or simply cycloaddition of azide and alkyne. As the students of postgraduate, they are studying pericyclic reactions. And in pericyclic reactions, they are studying this cycloaddition reaction. In addition to electrocyclic reactions, and then cycloaddition, and then some rearrangements. And in that case, either 2+2 cycloaddition or 2+4 cycloaddition type of reaction between carbon-carbon bonds. And here, Professor Sharpless and Melder found that there is a cycloaddition between azide and alkyne. Azide and alkyne in the presence of copper catalyst. In the presence of copper catalyst, and that copper may be in the form of copper salts, maybe in the form of sulfate of halides, or later on maybe in the form of nanomaterials, in the form of oxides also. See, it is nothing but the cycloaddition reaction of terminal azide and terminal alkyne in presence of copper catalyst, leading towards the 2+3 cycloaddition reaction resulted into the 1,2,3 triazos. And meantime, Professor Caroline Bertrozzi have taken the concept of bioorthogonal reaction. What is this bioorthogonal chemistry? As rightly mentioned by Principal Dr. Mazhar Farooqi sir in his keynote address, one of the area Professor Bertrozzi have explored the reactions, chemical reaction can be carried out in living systems. Can be carried out in living system, and how to utilize some portion from the living system and some portion from the chemistry. Okay, chemical molecules or chemical material. Means one of the functional group from chemistry and another functional group from living system can be utilized for making some useful molecules. And Professor Bertrozzi have made those useful molecules are nothing but 1,2,3 triazole without use of copper catalyst. This metal-free cycloaddition reaction between azide and alkyne without catalyst and leading towards the 1,2,3 triazoles. But what kind of substrate they have used? That is also important thing. See, Professor Bertrozzi have used one of the substrate is from living system. Yeah, see, it's a simply I can share my audio. Means I can tell you the concept exactly without showing any kind of video. See, this is the azide. This is the azide. This is alkyne because carbon-carbon triple bond is there, and you have a azide molecule. There is a reaction between azide and alkyne via 2+3 cycloaddition reaction in the presence of copper catalyst. In the presence of copper catalyst, resulted into the 1,2,3 triazoles. Many times there was a question from the audience why it is called as a click. Why it is called as a click? It is not an exact name of that particular reaction. Okay, and click reaction is not only this cycloaddition between azide and alkyne. It is a group of reaction. It is a group of reaction. Wherever you are getting 100% atom economy, we can call it as a click reaction. And see, we are putting, while driving the car, we have this seat belt. See, the two portions, we are coupling over here. See, and whatever sound is coming, that sound is nothing but click. Means two starting materials are reacted to each other by using some copper catalyst, resulted into the molecule without any side products. means this reaction is 100% atom economy, like Diels-Alder reaction. Okay, see, as this is one of the reagent, this is another reagent, means this is the alkyne and this is the azide, and there is a formation of carbon-nitrogen bond takes place. Carbon-nitrogen bond, and see the azide, N double bond N, that N is positive and double bond N negative. RN3 is there, and here is this is a one R group and carbon-carbon triple bond. Formation of triple bond is converted into double bond only. That's why this is a cycloaddition reaction and it is a
फक्त पाणी जावं बेस्ट आता हे बांधणारे वगैरे त्यांचे शेतकरी संशय आपण किती
hello, please mute yourself. Yeah, see, this is the beautiful example of click reaction between azide and alkyne. Alkyne with the help of copper catalyst. Later on, what Bertrozzi have done? Bertrozzi have taken cyclic alkyne, for example, octine. See, this is the octine molecule. There is a carbon-carbon triple bond is there. And this cyclooctane along with some glycan which contains azide. So glycan is a living system. And without using any catalyst, there is no need of copper catalyst. It resulted into the triazole over here. See, there is a carbon-nitrogen bond as well as a conversion of that C triple bond C to C double bond C. See, over here, see, as we have this terminal azide, we have this terminal alkyne, resulted into the 1,4 disubstituted. See, the presence of some substituent over here. This is a 1, 2, 3, and 4. This is a 1,4 disubstituted triazose. Now, in earlier drugs, we have seen that is a fluconazole, which contains 1, 2, 4 triazole. Here, it contains 1, 2, 3 triazoles. And see, simply, this is a terminal azide, this is a terminal alkyne. When these two substrates are coming to each other in presence of copper catalyst, resulted into the 1,4 disubstituted. See, this is 1, 2, 3, 4. 1,4 disubstituted 1, 2, 3 triazose. And as I shown that, it is like a seat belt, or what we can call it. There is a carbon-nitrogen bond formation reaction, but not a single carbon-nitrogen. There is a carbon-nitrogen, 2 bonds here. And that triple bond is converted to double bond. Okay, with the help of copper catalyst. See, on the same day, 5th October, Professor Kelly Sharpless have received a Nobel Prize. And he is the only fifth person who have received 2 Nobel Prizes for his great contribution. Prior to 2022, he has received a first Nobel Prize in the year of 2001 for his contribution in asymmetric oxidation reaction. As there are students from PJ as well as UG, they have studied Sharpless asymmetric epoxidation reaction, Sharpless asymmetric dihydroxylation reaction, with the help of some ligand, chiral ligands are here, chiral catalyst, DHQD FAL. Sharpless asymmetric amino hydroxylation means it is a one kind of asymmetric oxidation reactions. And first Nobel Prize he has received in the year of 2001 and second Nobel Prize in the year of 2022. Okay, now simply how this reaction is carried out and what are the advantages of this particular reaction. As I said that the azide as well as alkyne in presence of copper catalyst resulted into the 1, 2, 3, 4, 1, 4 disubstituted 1, 2, 3 triazose is nothing but click reaction. And click reaction or click chemistry is a simple name for a simple set of reaction. It is not a named reaction. Named reactions are different. Okay, we can call it Sharpless asymmetric epoxidation. That is a named reaction because it is discovered only by Sharpless. Here, Sharpless, Meldon, and Bartolsi, they have discovered a set of reactions, and that's why. And Sharpless have coined the term that is a clique. And the core of the clique chemistry concept is the cultivation of small set of reactions that are extremely ideal for working with organic molecules. And Sharpless have mentioned in his famous paper of Anglichem International Edition in the year 2001, a clique reaction would be modular, be wide in scope, means substrate scope. It may be donating, withdrawing, labile, acid, base, sensitive, we can call it. It should be wider in scope, means the reaction conditions should not affect on the substrate. See, on the substrate, that is important. Gives very high yields. As I told you, it is 100% atom economy, and the only product will form. Generate only inoffensive byproduct, easily removed. And it is a highly stereospecific, required simple reaction condition. That is important. Means this particular reaction one can carry out at any place. Those who are having only magnetic stirrer and electricity, RB flask. Okay, and they should have a two starting material along with the catalyst, and the reaction can be performed at room temperature. See the technology, as rightly mentioned by Dr. Tade sir. No doubt he has covered almost all points, and on single slide one can deliver a talk for more than 3 hours on his single slide. Okay, required simple reaction condition, required readily available reagents and starting materials. Means those reagents and starting materials should be available in the PG lab. In the PG lab, I can consider, or in the UG lab also. Okay, required no or benign solvent or easily removable solvent. About the benign solvents. Okay, or that solvent can be removed easily. Okay, and required simple product isolation and purification. There is no need of flash color chromatography. By means of simple crystallization also you can remove unreacted starting materials. Use products that are stable in physiological conditions. Important aspect of drug discovery process. Your product should be highly stable under physiological conditions. That is important. Okay, and then as I mentioned that this particular reaction is 100% atom economy, like a Diels-Alder reaction, like a Diels-Alder reaction. Okay, now see the journey of clique chemistry or this clique reaction. As I mentioned, Professor Sharpless have published his first paper in the Journal of Anglichem International Edition in the year of 2001, along with his students M.G. Finn and one more name of the student, just I have forgotten, Cole and Finn. They have worked on this one as per the directions of Professor Sharpless. And they have published the first paper in the year of 2001. And see the journey in the year of the number of papers 750 for the year 2010. For the year 2015, the number of papers 1,300. For the year 2021, 1311, 2022, 1290. And for the year 2023, 104. And this is the date of February 012023 at 11:45. Now the number may be here around 500. Around 500, I don't know, it may be 300 or 400. But see, from 2001 to 2023, the total number of publications are more than 18,000. And definitely the number will increase in this particular year because many more people, not only from the world, from India, but also from Maharashtra, they are working on this clique chemistry. And I think Dr. Marje sir, you have given me opportunity very first time at Aurangabad at Aurangabad, I am delivering a talk on click chemistry. Prior to this, from the Nobel Nobel Prize given to the Sharp Place at 5th October 2022. This is my 25th lecture all over the India as well as abroad. Okay, see the scope of this particular concept, click chemistry concept. Total number of publications are 18,000 so far. And see, no doubt, we have seen the fundamentals of click chemistry so far. There are some drugs available in the market which contains 1, 2, 3 triazole skeleton. See, this is the 1, 2, and 3. Means not only 1, 2, 4 triazole based antifungal agents, but also 1, 2, 3 triazole based drugs are available in the market, like carboxyamidotriazole. In short, it is called as CI. Then this TSAO is also available in the market, which contains 1, 2, 3 triazoles. And this cephalosporin cepatriazine, again it have the skeleton 1, 2, 3 triazole, and this tazobactam, which is an antibiotic, beta-lactam based drug having 1, 2, 3 triazoles. And recently we have seen the synthesis of this tazobactam drug in Oakheart, and I have read that particular paper, and I want to congratulate the people, those who are involved in the process development of this particular tazobactam drug. Okay, and many more molecules are in clinical phase trials 1, 2, 3. Okay, and several researchers are working on this particular 1, 2, 3 triazoles by using click chemistry approach. See, the biological significance of the 1, 2, 3 triazole based molecules. These molecules act as anti-cancer agents, anti-HIV, anti-inflammatory, anti-hepatitis C virus, anti-diabetic, antibacterial, anti-tubercular, antifungal, Alzheimer for the treatment of Alzheimer disease also. And not only in therapeutic properties, but also this triazole chemistry or click chemistry is used in material science. This is also used in polymer chemistry as well as in biological sciences. Okay, not only in chemical sciences, but in all. Hello, participant, please mute yourself. Yeah, these are the pharmacological significance of 1, 2, 3 triazoles. With this, we have undertaken this particular project not from 2022, but prior to that one, we have initiated this particular work in the year of 2010, means 12 years before, and started working on click chemistry for the design of new small molecules and their therapeutic properties. And the starting materials should be available in the postgraduate laboratory or in the department. And the reaction conditions, whatever we have used, they are very much simple, we can say. At room temperature, the reaction conditions are there. And without using any exotic reaction conditions, harsh reaction conditions. And the products were separated very easily. And later on, we have screened all these compounds for their various therapeutic properties. Okay, see, accordingly, we have designed the molecules. That's why my topic is contribution towards click chemistry, medicinal attributes. See, as we have seen that the click chemistry is nothing but cycloaddition reaction between terminal alkyne and terminal arside by using copper catalyst under click chemistry approach, leading towards the 1,4 disubstituted 1, 2, 3 triazoles. And we have designed such kind of molecules having a triazole skeleton. See, this is the 1, 2, 3 triazole as well as 1, 2, 3, 4 means they are 1,4 disubstituted units. And we have seen how this triazole displays drug-like properties, and this aromatic skeleton, see these two aromatic parts, they are lipophilically controlled. As well as we have designed the molecule on the basis of some molecular hybridization approach. And we have docked such kind of molecules against the TB enzyme, that is a DPRE1 enzyme. And accordingly, with the help of some theoretical predictions, we have designed and we have synthesized such kind of molecules. And after synthesizing the molecules, we have screened for their biological activities. And I will show you how the synthesis is very much simple. See, the commercially available phenols are the starting materials which are available in the PG lab, and they are simple phenols: phenol, chlorophenol, nitrophenol, cresols. It may be ortho, meta, and paracresol. They are alkylated. See, there is a free OH group, phenolic OH group, on reaction with potassium carbonate followed by propargyl bromide, and the only chemical which is required to make terminal alkyne, and remaining chemicals are available in the PG lab. See, on alkylation with propargyl bromide resulted into the terminal alkyne with ethereal linkage. Terminal alkyne. Now we have one starting material, and there are 7 starting materials we have prepared over here, terminal alkyne, and we need a terminal azide. See, terminal azide we need, and those terminal azides, benzyl azides, they are made from commercially available benzaldehydes. Simply 5 benzaldehydes we have taken over here. It may be benzaldehyde, nitrobenzaldehyde, fluoro, bromo, benzaldehyde. This aldehyde group were subjected for reduction into benzyl alcohol by using sodium borohydride. Further treatment with a PBr3, or you can use a HBr also, or you can use a thionyl chloride or PCl5O, because we need living group. Okay, we need a living group. This benzyl alcohols were subjected with PBr3, resulted into the benzyl bromide, followed by nucleophilic substitution of sodium azide. Resulted into the benzyl azides in excellent yield. Okay, we have a 5 azides and we have a 7 alkyne by using click chemistry approach, click chemistry reaction condition, click reaction conditions, using copper acetate, tertiary butanol water. See, these are a benign solvent which can be removed easily, or they are water soluble tertiary butanol. And the reaction is carried out at a room temperature. Here I have mentioned room temperature for 19 to 28 hours. Resulted into the 1,4-disubstituted 1,2,3 triazoles. And around 35 molecules, new molecules we have prepared with the help of click chemistry approach. And these are the structures of all those 1,4-disubstituted 1,2,3 triazoles, having the substituents like fluoro, nitro, bromo, either on phenol ring or on benzyl azide ring. See, these are the structures of all the 35 newly synthesized compounds, and all these compounds were characterized by means of spectral techniques like IR, H1-NMR, C13 NMR, as well as HRMS, and sometimes we have taken LCMS also, or EIMS also. We have characterized by means of all these spectroscopic techniques, and furthermore, we have screened these compounds for their anti-tubercular activity by using this strain, that is a MTBS37RA, and antioxidant activity also. And we have determined their MIC as well as IC50 value by using the standard drug rifampicin, and the antioxidant standard drug is a butylated hydroxytoluene and ascorbic acid. First of all, we will see about the anti-tubercular activity, and some of the compounds are showing lower IC50 value like 1.1 microgram per ml, 0.7 microgram, 0.5 microgram per ml, 0.8, 0.2 microgram, 0.8, 0.9 microgram per ml IC50, as well as a lower IC50 value. In addition to this, some of the compounds we have evaluated for their antioxidant activity, and the activity data for the standard drugs like a 16.5 microgram per ml, and see our synthesized molecules values 10.1, 10.9, 12.1, 11.0 means lower than the standard drug, means our synthesized compounds are showing better antioxidant activity. Furthermore, as just a minute. Hello?
Yes, sir.
Yeah, but a slide is not moving. I don't know the reason. Just
Just you have to minimize that slide.
I will stop sharing. Yeah, again I will present.
Okay.
Yeah. There may be, I don't know, some technical problem is there, and we have to adopt the technology also.
Yes.
Yeah. Just 1 minute, sir. Again, the same problem.
Okay.
Yeah, meantime, somebody may have any kind of queries because many more people have raised their hands. You can ask me orally. Meantime, we can resolve the issue. Hello, participant. Sir, there is some technical problem. I have to leave the meeting and I will rejoin the meeting. Madhya, sir.
Okay, sir. Very soon, Dr. Papa Sinte will join the meeting.
Hello, Marje sir, am I audible?
Yes, sir, you are audible.
Yeah. Sorry for some distractions because of network issue. Just we have started talking about click chemistry, and just first work I have shared with you, and a lot of click chemistry is remaining, and I should not conclude. That's why just wait for 4 to 5 minutes. If you have any queries in meantime, you can ask me directly. Yes, in Marathi we can call it internet issue was there, and because of internet issue, my laptop was came into hang, and I have to restart my laptop, and again I have to share my presentation. Participants, if you have any queries, doubts, or you want to ask anything, you can raise. Hello. मार्जे सर चॅट बॉक्स मध्ये कोणी काय लिहिलेलं आहे का बघा.
नाही, प्रश्न काही विचारलेले नाही चॅट बॉक्स मध्ये काही.
ओके ठीक आहे.
From audience, if you have any questions regarding these presentations, you can ask from audience.
Meantime, I can share my presentation. Just wait for 5 minutes because it's going on, and I can't do anything. I have to wait.
This is called a technology.
Yeah. Sometimes it happens, sir. Very few times.
Yes.
Yeah. कारण एकदम सडन जर इंटरनेट तुमचं गेलं तर काही करू शकत नाही.
Correct.
Yes, student participants.
If student participants are here, you have to ask any question related to the chemistry.
Yeah. Not only research, but also if you want to ask anything. Yeah. That is the main fault from our side. मराठवाडा. Yeah, sir, इंटरनेट गेलेलं होतं बाल. त्याच्यामुळे तो प्रॉब्लेम. Because of that. लॅपटॉप चालू झालेला माझा, पण जस्ट आय हॅव टू वेट फॉर सम टाइम अगेन. नेटला कनेक्ट करतो मी. Which is the best synthesizer? Yeah, someone have written. Can you read, sir, please?
Just one, sir.
Yeah, someone have written in the chat box.
Which is best synthesized molecules or series during your research? Which is best synthesized molecule or series during your research?
Yeah. Tade sir have mentioned. Yeah. Tade sir have written. Yeah. Sir, there are several series which got some excellent results, and some of the molecules, they are showing a twofold or threefold activity as compared to the standard drug. And just spot from my mobile, and I will rejoin just within 1 minute. Yeah, there are several series, sir. Several series. Just I will share with you. And we have studied excellent structure activity relationship also.
Okay, laptop start झालं का?
हो होतं ना, त्याला कनेक्ट करतो ना आता हॉटस्पॉट.
Okay.
पण मला मोबाईल वरचा ऑफ करावा लागेल सर.
हो.
Yeah, third is, sir, whether 5 members are more active. Yes, sir. सर मी लेफ्ट होता येतो ना.
Okay, okay. पार्टिसिपंट्स मधून कोणाला फीडबॅक द्यायचा असेल या सेमिनारचा तर देऊ शकता. थोड्या वेळात डॉक्टर बापू सेंटे जॉईन होतील. तोपर्यंत आपण ओव्हरऑल नॅशनल वन डे सेमिनार बाबत फीडबॅक द्यायचा असेल कोणाला तर देऊ शकता.
हॅलो,
हा येस सर.
आवाज येतो का माझा?
हा येतोय, आवाज येतोय.
ओके ओके. Sorry for technical issue from my side. It's extremely sorry. Yeah, slide is visible, sir.
Yes, sir. Slide
Yeah. Just 1 minute. हॅलो,
येस सर.
येतोय का आवाज व्यवस्थित सर?
येतोय, आवाज येतोय.
का इको येतोय?
हा नाही येतोय, आवाज येतोय. थोडासा इको आहे पण येतोय, आवाज स्पष्ट येतोय.
Okay. We have seen these molecules and their anti-tubercular activity, and furthermore, with the help of molecular docking study, molecular docking study, we have docked the most active compounds against the active site of DPRE1 enzyme, and there are excellent interactions molecule and amino acid. And in short, the most active compounds with a lower MIC value or IC50 value for anti-TB as well as antioxidant activity. Furthermore, screen these compounds for their cytotoxicity study. The strain like a THP, cancer THP1 A549, the PAN-C, and none of the compound toxic against all these cell lines. Furthermore, we have also performed in silico ADME property, as Dr. Tayde sir mentioned about consumption, distribution, metabolism, and compounds are excellent ADME properties or drug-like properties. In our first attempt, we have seen actually available phenols we have used, and we have prepared benzyl azides from corresponding benzaldehyde. In our next attempt, in place of these benzyl azides, we used the azide strategy. In place of benzyl azides, we have used based azides. In our next attempt, this work has been published in the Journal of Medicinal Application. As I mentioned, in the next attempt, the phenols we have kept a constant, and we have introduced this amide, because amides are very much important in the drug discovery process. Amide-based molecules are more active. Accordingly, we have designed such type of molecules from phenols as well as commercially available anilines. See over here, as we have seen already, phenols are subsequently converted into alkyne. Anilines were subjected for reaction with a chloroacetyl, means chloroacylation of, and followed by treatment with the sodium azide resulted into the alpha-azido. See, this alpha-azido acetamide formation technique. And we have made around such kind of azides, 7 azides, synthesized alkynes, and for copper with the help of click chemistry approach, optimizing reaction conditions like copper acetate, liquid chemistry approach, we came to the conclusion that reaction condition is highly suitable. Some ultrasound irradiation techniques, 35 to 40 minutes, to the amide-based 1,4-disubstituted triazose. And these are the structures. All these. Okay, these are the structures, and furthermore, characterization with the help of spectroscopic techniques and screen for their fungal activity against different fungal strains like a CA, FO, AAF. Yeah, and this red data shows that these synthesized compounds are highly active compared to the standard drug, antifungal drugs, that is a miconazole. However, none of the synthesized compounds shows better anti-tubercular activity. Audible. येतोय का मार्जे सर?
Hello. Yes, it is.
Yes, audible,
We
sir,
are
audible.
screening our synthesized compounds for their antioxidant activity. Of the compounds are showing better antioxidant activity as compared to the standard drug, that is a beauty. And we have studied furthermore for their this particular work is published in the Journal of RSC Advances. Hello, Marje sir.
Yes, sir.
आवाज येतोय का माझा?
येतो येतो आवाज येतो.
पण डबल येतोय मलाच आवाज. Yeah, in our further attempt, just in our initial attempt, we have considered available phenols as a starting material. We have introduced this ketone moiety, this astrophenol type of system is there, and this ketone can be further elaborated for many and we know very well if just 1 minute, sir. मार्जे सर, आवाज येतो का माझा?
हा येतोय सर, आवाज येतोय.
आणि स्क्रीन दिसते का?
हॅलो.
स्क्रीन नाही दिसत आहे बाप्पू, ऑडिबल आहे.
ओके ओके, ऑडिबल म्हणजे मी मोबाईलवरून जॉईन केलेलं आहे सर. सर तायडे सर, देयर इज सम प्रॉब्लेम, आय डोंट नो.
ओके सर.
हा हॅलो.
हा आवाज येतोय सर.
सर बरोबर आहे तुमचं, आवाज येतोय क्लिअर.
आवाज मी मोबाईलवरून जॉईन केलं सर, प्रेझेंटेशन स्टॉप केलेलं होतं, आता परत एकदा बघतोय मी. इको होता, त्याच्यामुळे मी ते बंद केलेलं होतं. इको होता, खूप इको. Meantime, I will tell you orally, in our first attempt, we have started synthesis of the molecules by using phenols, commercially available phenols, and benzyl azides. We got 1,4-disubstituted 1,2,3-triazoles. In our second attempt, what we have made, we have changed azides in place of benzyl azides. The azides were derived from anilines. Anilines on reaction with chloroacetyl chloride, it gives a chloroacetamide derivative. And furthermore, we have done nucleophilic substitution reaction with sodium azide. Sodium azide resulted into the alpha azidoacetamide derivative formation takes place. And then the already synthesized phenols were subjected for click reaction by using copper acetate with the help of some ionic liquid, that is a medium, and we have reduced the time from 19 hours to just simply 40 to 45 minutes. Within 45 minutes, we could be able to complete that particular reaction. And in the next attempt, just I will share my slide, sir. हॅलो.
हॅलो सर.
मला अलाव करा, मी दुसऱ्या ह्याच्यावरून इन्स्ट्रुमेंटवर जॉईन झालेलो आहे. Hello, am I audible, sir?
Yes,
Yes, sir, you are audible.
Yeah, see here, now I will read that things. We have started the synthesis from commercially available phenols. Phenols were subjected to acetate derivative and followed by Fry's rearrangement, as we are doing regularly in postgraduate laboratory. And we have orthohydroxyacetophenols. One is a commercially available orthohydroxyacetophenol, and another one is rearrangement. Okay, and acetophenols were subjected for propargylation by using propargyl bromide and potassium carbonate, resulted into the terminal alkyne. We have a 3-terminal alkyne which is having a acetophenone core in the structure, and we have already synthesized the benzyl azides under click chemistry reaction condition by using copper acetate, tertiary butyl water soluble system, resulted into the 1,4-disubstituted 1,2,3-triazoles having a ketone moiety open for further transformation. And our group is working on that ketone furthermore to incorporate so many other pharmacophoric groups over here with the help of this ketone. As a Tide sir, as well as a Marge sir knows, if you have a new acetophenone in your hand, you can make billions of the compounds. And this is the new acetophenone which we have introduced the very first time. And people have exploited this particular acetophenone to make many more compounds. one story I want to tell you over here. We have made orthohydroxyacetophenone, but other people have started quickly. Why not to work on para-hydroxyacetophenone? It means that lot of work has been done on this orthohydroxyacetophenone derived 1,4-triazoles. See, these 18 compounds we have synthesized and characterized very well by means of spectroscopic techniques and screened for their antifungal as well as antioxidant activity. And some of the compounds are displaying good antifungal activity as well as antioxidant activity with lower IC50 value. Furthermore, these compounds were docked against the active site of styrol 14-alpha demethylase, where the compounds, most active compounds, are showing better interactions with different amino acids of that 14-alpha demethylase. And these are the most active compounds derived from orthohydroxyacetophenone with a lower MIC value for antifungal activity. And this work was published in the Journal of Chinese Chemical Letters. And right now, the impact factor of this particular journal is around 9. In our next attempt, we have changed only phenols in place of phenol. Why not to take some pharmacophoric group, which is a coumarin based, and this coumarin based various drugs are available in the market, like warfarin. One of the drug is available in the market as an anticoagulant. Not only this, but also many more drugs having a skeleton coumarin. And just we have changed in place of those plain phenols which are available in the PG lab. In place of that plain phenol, these coumarins, and these coumarins can be made easily in postgraduate laboratory. And see, our first attempt with the help of Pitchman condensation reaction on resorphenol by using ethyl acetate and sulfuric acid resulted into the 7-hydroxy-4-methyl coumarin. And this particular practical we are giving to the postgraduate student. And around 40 students have performed this particular synthesis of 7-hydroxy-4-methyl coumarin. And 1 gram each 1 gram compound made by each student, and just collected those 40 gram of 7-hydroxy-4-methyl coumarin and purified once and utilized for making this propargylated coumarin based molecule. And this propargylated coumarin based molecule further reaction with copper acetate, tertiary butanol, water solvent system under click chemistry condition and already synthesized benzyl azides resulted into the coumarin based 1,2,3-triazoles. Means here we have incorporated 2 pharmacophoric groups in a single molecular motif and may displays better activity, even though individually coumarin and individually triazole displays different types of biological activity. But in combination of these 2 pharmacophoric groups in a single molecular motif may display better activities. In further, we have taken 4-hydroxy-coumarin, which is made from the plain phenol and reaction with malonic acid under POCl3 condition resulted into the 4-hydroxy-coumarin. And this phenolic OH group is a free, which is alkylated by using propargyl bromide, resulted into the terminal alkyne and already synthesized these 6 benzyl azides on reaction with this 23 compound resulted into the coumarin based 1,2,3-triazoles. And these are the structures characterized very well and screened for their anti-TB, antioxidant, antibacterial and antifungal activity. And see here, some of the compounds are showing a good anti-TB, not excellent, but good anti-TB activity and good antioxidant activity. However, all the synthesized compounds are showing better antibacterial against the gram-positive bacteria and gram-negative bacteria, as well as excellent antifungal activity as compared to the standard drug like microzole and fluconazole. As these synthesized compounds are showing good antitubercular activity, we have doctored these molecules against the DPRE1 enzyme and shows a better interactions with different types of amino acids. And these are the most active compounds against TB as well as antioxidant and antimicrobial activity. And this work is published in the Journal of Medicinal Chemistry Research. In our further attempt, the commercially available resorphenol on Wilsberg formulation reaction by using POCl3 DMF resulted into the 4-hydroxy-salicyldiide. Simply means 2,4-dihydroxybenzaldehyde, which on non-benzyl condensation by using diethyl malonate followed by cyclization resulted into the hydroxylated coumarin. Further on alkylation and reaction with benzyl azide under click chemistry condition, that is copper acetate, tertiary butanol water, resulted into the coumarin based 1,2,3 triazoles. And these are the structures and screen for their antifungal as well as antioxidant activity, and docked against the enzyme, that is a sterol 14 alpha demethylase, and showing a better interactions. And these are the most active compounds, and the work is published in the Journal of Chinese Chemical Letters in the year of 2016. In our further attempt, here we have used only benzyl azides. Here we have changed the azides, and we have kept the coumarin moiety as it is, and the azides, which we have seen how to prepare it from the corresponding anilines on chloroacylation followed by nucleophilic substitution with sodium azide, resulted into the azidoacetamides, and already synthesized coumarin based alkynes were with us, and reaction with alpha azidoacetamides in presence of copper acetate tertiary butanol water resulted into the coumarin based 1,4-disubstituted 1,2,3 triazoles having a amide functionality in their structure. And these are the structures and evaluated for their antifungal activity, and some of the compounds are showing 2-fold or 4-fold antifungal activity as compared to the standard drug. However, none of the synthesized compound is showing better anti-tubercular activity, and one compound is showing excellent antioxidant activity. And we have docketed the most active compounds against the active site of cytochrome P450, lanosterol 14 alpha demethylase, and showing better interactions. And this particular work is published in the Journal of Arch Pharma, having impact factor around 4.8. So far, we have converted phenols into alkynes. Here, we have changed the strategy, and in place of phenolic OH group, we have considered here isatin as a backbone, and isatin is available in various drugs, and just we have inserted or we have tethered or we have appended triazole moiety over isatin backbone, and we have designed such kind of molecules and synthesized from commercially available isatin on alkylation. We have terminal alkyne, and this terminal alkyne on reaction with already synthesized benzyl azides under click condition resulted into the 1,4-disubstituted 1,2,3 triazoles having a isatin moiety. In our further attempt, this alkyl propargylated isatin on reaction with aryl azides, which were prepared from corresponding anilines on the diazotization followed by substitution with sodium azide, resulted into the corresponding isatin based 1,2,3 triazoles. And these are the structures characterized very well and screened for their anti-tubercular activity and antioxidant as well as antifungal activity, and some of the compounds are showing better antifungal activity docked against the cytochrome P450 lanosterol 14 alpha demethylase of Candida albicans, and better interactions were displayed by the compounds. And these are the most active compounds, studied their cytotoxicity against the 3 cell lines as well as ADME properties, theoretical ADME properties, and this work is published in the Journal of Heterocyclic Chemistry. In our further attempt, in place of isatin, we have changed over here benzthiazinone. Benzthiazinone based various drugs are available in the market, as well as people have modified this benzthiazinone to make some bioactive molecules, and accordingly we have designed to introduce benzthiazinone in the molecule along with a triazole skeleton. And this benzthiazinone is prepared from commercially available orthoaminothiophenol on reaction with chloroacetic acid in presence of sodium acetate, or you can take chloroacetyl chloride, you will get this benzthiazinone. We have free NH group which on reaction with the propargyl bromide in presence of sodium hydride in DMF resulted into the only one alkyne, and we have already synthesized a benzyl azide as well as aryl azides in presence of copper acetate room temperature stirring in tertiary butanol water, resulted into the benzthiazinone based 1,2,3 triazoles. And these are the structures screened for their anti-TB activity against the 2 TB strains, that is MTBS37RA and M. bovis BCG strain, as well as antioxidant activity, and some of the compounds are showing better anti-tubercular activity and showing a better interactions with the different types of amino acids. And these are the most active compounds, and studied their cytotoxicity against the 3 cell lines, as well as we have performed ADME properties. And this work was published in the Journal of Bioorganic and Medicinal Chemistry. Furthermore, Just we have changed our one of the pharmacophore group in place of benzthiazolone. Why not to take aryleidine thiazolone? Because aryleidine thiazolone, this backbone is available in a various anti-diabetic drugs, that is rosiglitazone, pioglitazone, as well as such type of compounds are displaying anti-inflammatory activity. That's why not to incorporate triazole moiety over 2,4-thiazolone, means two pharmacophore groups introduced in single molecular motif may display better activities. And accordingly, we have synthesized from commercially available thiazolidinone, or we can make from fluorastic acid and thiourea. This thiazolidinone on nominal condensation with benzaldehydes, only 3 benzaldehydes, which resulted into the aryleidine thiazolidinone, which were alkylated by means of propargyl bromide, resulted into the 3 propargylated thiazolidinone. And furthermore, reaction with the benzyl azides, which were already prepared by using click chemistry reaction condition, resulted into the thiazolidinone based 1,2,3 triazoles. These are the structures and screen for their anti-inflammatory activity. And I want to tell you over here that diclofenac sodium, which is an anti-inflammatory drug, showing the EC50 value is a 0.72, but our synthesized compound 26O.84 means equipotent. Furthermore, the compound number 26E showing the 0.64 means better than the standard drug, that is a diclofenac sodium, as well as these two compounds 26C and D, they are showing 0.8 and 0.7 EC50 value, that is a microgram per ml value. Furthermore, almost all compounds are showing better antioxidant activity. However, none of the synthesized compounds showing any kind of anti-tubercular activity. And furthermore, we have studied if they are not showing any kind of anti-tubercular activity, it means that they may show excellent antimicrobial activity. As Dr. Tade sir have already mentioned about this one, antimicrobial activity, that is antifungal as well as antibacterial against different kinds of bacterial and fungal strains. And almost all compounds are showing excellent antibacterial and antifungal activity. Furthermore, as I have told you, one of the compound is showing equipotent activity as compared to the standard drug. Here, I am showing the docking image of that particular active compound against the PPA or gamma inhibitors, and showing excellent interactions with the different types of amino acids. And these are the most active compounds against and for anti-inflammatory activity as well as antioxidant and antimicrobial activity. And this particular work is published in the Journal of Polycyclic Aromatic Compounds, as well as we have published one patent and we have communicated one paper on antimicrobial activity, and very soon it will appear online. Okay, means one series of compounds can be made 3 different types of publications if you have studied different types of properties. In our next attempt, why not to utilize some drug type of compounds? See, some hydrazone type of moieties we have made, and here triazole core is there, and accordingly we have designed the molecules. See over here, para-hydroxybenzaldehyde on reaction with propargyl bromide resulted into the propargylated benzaldehyde, which on click reaction with benzyl azides resulted into the this aldehyde-based triazoles. These aldehyde-based triazoles were reacted with various acid hydroxides. One of them is INH, that is isonicotinic acid hydroxide, which is a drug. Here, nicotinic acid hydroxide and para-nitrobenzoic acid hydroxide. And simply we have made hydrazoles, and these are the 12 compounds, and these are the structures of all those 12 compounds, characterized very well by spectral techniques and screened for their anti-tubercular activity or antimicrobacterial activity, we can say. See, this is 20A, 20D, 20G, and 20J compound. Against the TB strain, MTBS37RA, MBOS, BCG, against dormant as well as active strain, we have determined IC50 as well as IC90 value, and this red data is showing excellent activity, equipotent activity as compared to the standard drug, and these are red numbers, that is 20A, 20D, 20G, and 20J, they are derived from the INH, means a direct drug. And this is the confirmatory test how INH is displaying excellent activity. Okay, and only INH based compounds are showing excellent activity over here. Yeah. This is the talking images for most active, and these are the most active anti-tubercular agents. And furthermore, we have studied their toxicity, and none of the compound is toxic against these cell lines, as well as we have analyzed the ADME properties. In earlier case, we have considered para-hydroxybenzaldehyde. Here, why not to take ortho-hydroxybenzaldehyde? Similar strategy we have used over here on alkylation, propargylation, followed by click reaction with the benzyl azides. And we have free aldehyde, and why not to treat this free aldehyde with acid hydroxides like INH, isonicotinic acid hydrazide, nicotinic acid hydrazide, para-nitrobenzoic acid, chlorobenzoic acid hydrazide, and para-methoxybenzoic acid hydrazide. Means, see over here, we have 5 acid hydroxides, and we have eight aldehydes. Means 40 compounds we have made, and these are the structures of all those compounds, characterized very well by means of spectroscopic techniques and screen for their anti-tubercular activity. And see here, 24A, 24F, 24K, 24P, as well as 25M, 25H, 25E, and 25A. These compounds are derived from and other compounds from nicotinic acid hydrazide, para-nitro, para-methoxy, and para-chlorobenzoic acid hydrazide. It means that the hydrazones derived from INH displays excellent anti-tubercular activity with lower IC50 value as well as a lower MIC value. As well as we have screened these compounds for their antioxidant activity also, and some of the compounds are showing excellent antioxidant activity. And these are the most active compounds, and this work is communicated to the excellent journal of medicinal chemistry, and hope so very soon it will be available online to all. And these compounds were screened for their toxicity, and none of the compound is showing any toxicity, and also ADME properties. In our further attempt, why not to change some azide in place of benzyl azide or amide-based azides? Why not to take some quinone-based azides over here? And accordingly, we have designed the molecules, started from metanicidine, simple one, and how to learn the total synthesis of molecules. That's why I have given this particular project to the students. Metanicidine on reaction with acetic acid gives acetaldehyde, which on Wilsmer-Huck formulation reaction resulted into the 2-chloro-3-phormylquinone. This on nucleophilic substitution with sodium azide resulted into the tetrazoloquinone aldehyde. This aldehyde group on reduction into alcohol, then furthermore methylation, and a nucleophilic substitution reaction with the sodium azide resulted into the azide. And we already synthesized alkyls from phenols, which on click reaction by using copper acetate resulted into the tetrazoloquinone based 1,2,3 triazoles, and these 9 compounds which we have made over here, and these are the structures and characterized very well, and furthermore screen for their antibacterial and antifungal activity. See the starting material, whatever we have used over here, that starting material is inactive against all the strains of bacteria as well as the fungi. However, our derived compounds, which is having 1,2,3 triazole skeleton in the structure, displaying excellent antibacterial as well as antifungal activity with a lower MIC values. See, and furthermore, we have docked the active compounds against the active sites of sterol 14 alpha demethylase cytochrome P451, and showing better interactions. These are the most active compounds, and also studied their ADME properties. With this, and this particular work is published in the Journal of Polycyclic Aromatic Compounds. With this, I would like to conclude over here. We have made a series of compounds derived from commercially available starting materials or available in the postgraduate laboratory. Only specific chemical was propargyl bromide, copper acetate, or sodium ascorbate or copper sulfate. Only this copper sulfate is available in kgs in inorganic chemistry laboratory, and the conditions which you have seen all are room temperature conditions. And here I have presented a part of work on the concept click chemistry, because I know the audience is from UG and PG students as well as some faculty members, no doubt. That's why I have made this a short presentation. And so far, we have published more than 35 research articles on the concept of click chemistry. And 5 students have received a PhD degree on click chemistry approach. And presently, 5 students are working on click chemistry. And in future, you may see excellent output from this study on the click chemistry approach for their medicinal use over here. And whatever work I have presented over here is carried out by Dr. Mubarak Sheikh. Presently, he is a faculty at Red Shikshan Sanstha. And some part is carried out by Dr. Satish Akolkar. Presently, he is working as a scientist at a Syngen industry at Bangalore. And remaining students, this Dr. Dnyaneshwar, now he's a group leader at some industry. Ashurba Danne, Tejasri Deshmukh, and Smita Khare, they are faculty members. All these people have carried out work on click chemistry, as well as this Madhya Siddiqui have also carried out work on click chemistry approach. And these students are also working on click chemistry approach. Only Dr. Dnyaneshwar Subedar and Amol Nagargoje have also carried out some part of click chemistry approach, but not in details. And without their contribution in the field of click chemistry, such kind of beautiful work is not possible. Not only these, but also so many collaborators from different parts of the India. Dr. Dhiman Sarkar, Dr. Jaiprakash Shetty, Dr. Mukundesh Pandey, Dr. Vijay Khedkar, Dr. Sandeep Shinde, Dr. Prakash Jha, Dr. D. Sriram, and many more collaborators from all over the India. They have supported this particular work, and I would like to appreciate their contribution in this field. And finally, I'm thankful to CSR, UGC, DST, and Dr. Babasaheb Ambedkar Marathwada University for their financial assistance. And sorry for interruption from my side because of internet issues. And I'm very much thankful to the organizers who have given me an opportunity to share my views regarding click chemistry approach. With this, I will stop over here, and thank you one and all. Yeah, participants, you can raise your queries, questions, either you can write in the chat box.
Yeah, from audience, if you have any questions regarding this presentation, you can ask. A lot of work has done by Dr. Bapu Singte. We cannot cover in a couple of hours.
It's a difficult to share all these works, all these work. It's a difficult. Yeah, Taide sir.
Yes, sir. Bapu,
Yeah.
whether you utilize 7-membered ring compound?
Yeah, sir. We have coupled triazole with a 7-membered ring also.
No. Not coupling. Whether you synthesize 7-membered ring.
No, we are not synthesizing. But we have coupled this triazole with 7-membered ring. No, we are not coupled.
Okay.
Okay, thank you, sir. Dr. Bapu Singte, sir, has given a very nice lectures on the click chemistry. He has covered the antituberculous drugs, antifungal drugs, and the journey of this click chemistry. I'm sure that your lecture will be very valuable and beneficial for our participants. On the behalf of Management, Principal, Department of Chemistry, Vasantrao Naik Mahavidyalaya Aurangabad, thank you very much, sir, for delivering a very nice lecture. Now, I invite Dr. Jayashree Chamragore Madam to propose the vote of thanks. Dr. Jayashree Chamragore Madam.
Good afternoon all. Thank you in such a prayer that cannot be seen or touched. It must be felt by heart. I, Dr. Jayashree Chamragore, feel honored and privileged to get the opportunity to propose a vote of thanks on this special occasion. I would like to thank all the honorable delegates who blessed us with their virtual presence. I am also very much thankful to all advisory committee members and the invited speakers Words are not enough to thank their constant guidance and support to shape the seminar. I, on behalf of organizing committee, convey deep regards and hearty thanks to our honorable president of our institute, Samaj Bhushan Rajaramji Rathod sir. I am also thankful to the chairperson of today's national seminar and secretary of Vasantrao Naik Mahavidyalaya Shri Nitinji Rathod sir. They help us in obtaining the necessary administrative approval for organizing the online event in our institution. They supported in all possible manners to organize the seminar. My special thanks to Professor Dr. Mazhar Farooqi sir, Principal Maulana Azad College, for his constant guidance that radiated a source of energy within us. We will ever remain grateful to you. Today, my words are not enough to express the gratitude to Farooqi sir, who graced us with his keynote address. I must mention our deep sense of appreciation for Dr. Rajesh Bhosle, head, Indrashil University, Rajput, Gujarat, for giving an excellent coverage to recent advances in chemical sciences and technology, like fluorescence spectroscopy analysis. I may like to express our sincere thanks to Professor Dr. Deepak Tayade, Government Vidarbha Institute Science and Humanities, Amravati, for giving an excellent coverage to today's need of interdisciplinary and scientific research. I also wish to express my gratitude to Dr. Bapu Shimte, Dr. Babasaheb Ambedkar Marathwada University, Aurangabad, for presenting topic on contribution towards thick chemistry, medicinal attributes. I would like to thank our beloved principal, Dr. Anand Chaudhary, head of the department, for their constant help and guidance that radiated a source of energy within us. I am very much thankful to all our current and former faculty colleagues and non-teaching staff members who always stand by us and motivate us. I feel proud and thank you for making this event a successful. I am immensely thankful to Mr. Talat Moniza Siddiqui for her efforts towards anchoring of today, her own ideas and elegance of explanation of everything. I need to mention my deepest sense of appreciation to her. I also extended my thanks to technical team for their enormous cooperation in organization of this event. If time is money, then today you have spent millions for us. Thanks for all of you, all of our participants, making this event successful. I want to make an important announcement for all participants about feedback form and certificate in WhatsApp group. Now, link for feedback form is provided. So please fill feedback form and submit it so as to generate your certificate in your mail. Once again, thanks to all of you. Completion of this national seminar followed by national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे